In this demonstration, I'm going to show you some of the core features of GitHub Copilot within VS Code and how they can enhance your development workflow. We are starting with the GitHub Copilot extension already installed in VS Code. I have VS Code opened on my screen in the default layout, with the Explorer sidebar on the left and the main editor area in the center. I'll need a project to properly demonstrate Copilot's capabilities. I'll open an application I've already started working on. This is a simple web application built with HTML, CSS, and JavaScript, a perfect candidate to showcase Copilot's features. Now, let's invoke GitHub Copilot. There are several ways to do this, but the primary method is through the Copilot chat interface. When first opening VS Code, GitHub Copilot doesn't have any visible elements in the default interface until we activate them. To access Copilot controls, I'll right-click on an empty space in the top menu bar at the very top of the window. Notice the option called Copilot Controls. This appears because I've already installed the Copilot extension in VS Code. When I click on Copilot Controls, you'll see the GitHub Copilot chat icon appear on the right side of the search bar in the top menu area. Clicking the chat icon opens the Copilot chat window on the right side of my editor, appearing as a new panel that takes up about a third of the screen width. This is where we can directly interact with Copilot by asking questions or issuing commands. Since this is a new application that Copilot hasn't seen before, a good first step is to ask Copilot to analyze our project. I'll type, "Analyze the app folder called HTML," and then press Enter. Copilot is now responding with a comprehensive analysis of the application structure. It's identified our HTML files, the images folder containing a GIF, and both the scripts and the styles we have in the project. As we continue through Copilot's response, it provides more detailed information about the CSS and JavaScript files in the project structure. Next, I'd like to demonstrate how Copilot assists with direct code suggestions. I'll close the Explorer window on the left side to create more space on my screen, giving us a clearer view of the code editor area. I've opened an HTML file that contains a form with email and password fields and a submit button. Now I will place my cursor at the end of the form and press Enter. Copilot is immediately suggesting adding a new field, a complete HTML input element for a first name field with appropriate labels and attributes. The suggested code appears in italics and a lighter gray color to distinguish it from code you've already written. This is Copilot's way of showing what it's suggesting before you accept it. To accept this suggestion, I just press the Tab key. Copilot completes the code, and I'll press Tab again to accept the closing div tag. Just like that, I've extended my form with a new field without writing a single line of code manually. Another powerful way to interact with Copilot is through comments. Let me open my JavaScript file from the scripts folder. At the bottom of this file, I'll add a comment. Add a function to add two numbers and return the result. As soon as I finish typing the comment, Copilot suggests a complete function named add, with two parameters that performs exactly what I requested. I'll press Tab to accept this suggestion, which confirms and incorporates Copilot's code completion into the rest of the code. Finally, let me show you one of my favorite features, inline chat for code refactoring. Let's focus on this for loop starting at line 8, which iterates through elements and applies styling to each one. What if I wanted to change this to use a more modern JavaScript approach? I'll highlight the entire for loop block from line 8, which includes the for statement and all the code within its curly braces. Now I'll press Ctrl-I on my keyboard to open the inline chat, which creates a small input field directly within the code editor where I can type instructions. Now I can give specific instructions that will only affect this highlighted section. I'll type, use an array function to accomplish the same result as the for loop, and press Enter. Copilot quickly transforms the traditional for loop into an array for each construction. I'll accept this suggestion, and my code is instantly refactored to an array for each method that performs the same function with modern JavaScript syntax. These examples demonstrate the three primary ways to interact with GitHub Copilot. Using the chat interface for project-wide analysis and queries. Receiving contextual code suggestions as you write. Utilizing inline chat for targeted code refactoring. Each approach provides powerful assistance that can significantly speed up your development process while helping you write better, more modern code. In this demonstration, I'm going to show you how to add GitHub Copilot to Visual Studio Code, covering the complete installation and configuration process. I'll start from scratch to ensure we cover all the steps. Currently, I don't have VS Code installed on this Windows system, so I've downloaded the installer. Let's begin with installing VS Code itself, and then we'll add the Copilot extension. I'm using the VS Code User Setup option for Windows. When you run the installer, you'll see Microsoft Visual Studio Code's license agreement. After accepting the agreement, you can select the installation location. I'll use the default C drive location. For setup options, I recommend creating a desktop icon for easy access. I'll also select additional options and ensure the option Add to Path is selected, which makes it easier to launch VS Code from the command line. Click Next to begin the installation process. The installation will take a moment to complete. Once it's finished, I'll click the Finish button and launch Visual Studio Code immediately. Now VS Code is opening for the first time. I'll maximize this window to get a better view of the interface. The VS Code interface displays a welcome page in the center with a vertical activity bar on the far left containing icons for different views, a sidebar next to it, and the main editor area occupying most of the screen. Let's check which version we're using by going to the Help menu and selecting About. We can see we're using version 1.99. Now let's proceed with installing GitHub Copilot. On the left side of the VS Code interface is a vertical activity bar with several icons. The extensions icon located below the search icon, it resembles four squares with one slightly separated. When you hover over it, it should say Extensions. Click on this icon to open the Extensions view. The Extensions view opens in the sidebar area to the right of the activity bar. It contains different categories arranged vertically, installed at the top, followed by Popular, and then Recommended extensions. Each category lists extension cards with their names, descriptions, and installation buttons. Since this is a fresh installation, we don't have any extensions installed yet. To install GitHub Copilot, use the search bar located at the very top of the Extensions view sidebar. This search field spans the width of the sidebar and is the first interactive element in the Extensions panel. Type GitHub and press Enter. One of the first options that should appear is GitHub Copilot. Click the blue Install button next to GitHub Copilot to begin the installation. Once installed, the blue Install button on the GitHub Copilot extension card changes to either Disable or Uninstall, confirming successful installation. The extension card also displays a green check mark indicating completion. Now let's verify that GitHub Copilot is working properly. There are a few ways to interact with Copilot. One way is through the Copilot chat interface. To access this, click on the View menu, then scroll down to find the chat option. Alternatively, you might see a Copilot icon in your sidebar or status bar, depending on your VS Code version. When you open the chat, a new panel appears at the bottom right of the VS Code window. This panel contains a text input field at the bottom for typing questions, with the conversation history displayed above it, similar to a standard chat interface. Let's test it with a simple question. I'll type "What IDE am I using?" and press Enter. Copilot responds correctly with "You're using Visual Studio Code," which confirms that the extension is operational and properly connected. In my case, GitHub Copilot worked immediately because I was already signed into my github.com account. However, your experience might differ. If you need to sign in, you'll be prompted to when you first try to use Copilot. If you need to sign up for GitHub Copilot, go back to the Extensions view and select the GitHub Copilot extension card. This opens the extension details page in the main editor area, replacing any previous content. Scrolling down in this details page reveals a section with blue hyperlinks, including Sign up for GitHub Copilot free. Clicking this will open your browser where you can create a GitHub account if you don't already have one, or sign into an existing account. You'll also find additional information about GitHub Copilot's features and capabilities in the extension details. I encourage you to explore these resources to better understand what Copilot can do for your development workflow. I want to remind you that this extension is always changing. Depending on when you are watching this demonstration, certain parts of the interface or the way we interact with Copilot may have changed. With GitHub Copilot successfully installed and configured, You're now ready to take advantage of its AI-powered coding assistance features. In our next demonstrations, we'll explore how to effectively use Copilot for various coding tasks. Let's begin this video by looking at the 3 top issues that may happen when you first start working with GitHub Copilot. First, network connectivity issues are among the most common problems. If Copilot does not connect or shows connection errors, your first step should be to verify that your computer's internet connectivity is properly established and working. This might involve basic troubleshooting like restarting your router if you're using one. In corporate environments, you may need to check proxy settings that might be blocking Copilot's connection to GitHub servers. A simple internet browser test can confirm basic connectivity, but remember that Copilot requires specific ports and protocols to be open. Second, even with a secure connection, the service might not start due to authentication issues. In this case, you'll need to re-enter your credentials or refresh them. Sometimes completely removing and re-adding your GitHub ID to the IDE itself resolves persistent authentication problems. This is particularly common after password changes or when your authentication token expires. Look for error messages mentioning unauthorized or authentication failed as indicators of this issue. Third, when the 2 previous issues are validated but Copilot's suggestions don't include certain files, file exclusion may be the culprit. Check that the content exclusion feature is turned off or review the settings if it's enabled. This may require a user with administrative privileges, especially in corporate environments where security policies might restrict which files Copilot can access or analyze. Look for Git ignore files or Copilot-specific exclusion settings that might be preventing analysis of specific file types or directories. If Copilot refuses to engage in VS Code even after addressing the fundamental issues we just discussed, try updating to the latest version of VS Code. Both GitHub Copilot and Copilot Chat extensions should be running their latest versions as well, as compatibility issues between outdated extensions and newer VS Code versions are common. Always check that your subscription has not expired, as this is a frequent cause of sudden functionality loss. For comprehensive setup guidance, refer to GitHub's Quick Start documentation. Depending on your subscription status, you might encounter connection errors where Copilot cannot connect to the server. In this scenario, signing out and signing back in may be required to obtain a new authentication token. If that approach fails, accessing Copilot's error logs can provide more detailed information about what's going wrong. These logs often contain specific error codes that you can reference when starting a discussion in GitHub support forums. You might notice that Copilot sometimes doesn't suggest multiple lines of code when clearly this type of response is expected based on context. At the time of this course's publication, this is a known issue that may have been resolved by the time you're watching this video. Check the GitHub Copilot release notes for updates on this behavior if you encounter it. If there's no validation token available, it may be a CLI-based error and usually indicates that a personal access token is already in use elsewhere. Remember that Copilot supports the OAuth 2 authorization framework. Try logging out of any other environment where you might be using Copilot, as simultaneous usage can sometimes cause token conflicts. Finally, GitHub implements rate limits to make the service available to as many users as possible and to protect against abuse. These limits ensure a reliable and consistent service level. If you receive an access denied message mentioning rate limits, you may need to wait before making additional requests. Enterprise users typically have higher rate limits than individual accounts. Most other Copilot access issues are related to how users interact with the software. These quality and usage concerns aren't technical problems per se, but understanding them can help you use Copilot more effectively. To start, developers may find themselves relying on Copilot so heavily that it affects their individual style and originality. While Copilot can accelerate development, it's important to maintain your coding voice and critically evaluate suggestions rather than accepting them wholesale. Consider Copilot a collaborative partner rather than an autopilot feature. Copilot's view of your coding environment may be limited, which could result in code suggestions that don't fully align with your project's architecture or requirements. The tool only sees the currently open files and lacks the comprehensive understanding of your entire code base that you are working on. Copilot chat has a defined scope, which may limit its effectiveness with particularly complex code structures or outdated programming languages. While it handles modern, mainstream languages like JavaScript well, you might encounter reduced quality suggestions when working with uncommon technologies or legacy systems. It's possible for Copilot to suggest code with obvious security issues. A common example is including hard-coded credentials or secrets in its response. Always review security implications of suggested code, particularly around data handling, authentication, and input validation. The quality of code suggestions is directly proportional to the amount and diversity of training data that was used for that particular language or framework. This means Copilot generally performs better with widely used technologies and standard patterns than with emerging or specialized frameworks. Copilot may occasionally provide responses that lack clarity, completeness, or readability. This is particularly true for complex algorithms or specialized implementations where there might be fewer high-quality examples in the training data. Copilot may not always be able to provide context or explain its choice of logic. Unlike a human pair programmer, it can't discuss the reasoning behind a particular implementation approach unless specifically prompted to do so. While Copilot excels at generating boilerplate code, that code may not always meet your specific expectations or requirements. It generates code based on patterns it has learned, which might not align with your project's specific needs or coding standards. Finally, there's always a risk of encountering sensitive, copyrighted, or otherwise IP-protected code in Copilot's responses. While GitHub has implemented filtering to reduce this risk, it's ultimately your responsibility to ensure that code you incorporate into your project respects intellectual property rights and licensing requirements. Understanding these potential issues will help you develop strategies to maximize Copilot's benefits while mitigating its limitations, leading to a more productive and effective development experience. In this demonstration, I'm going to walk you through the interface elements of GitHub Copilot, focusing on the Copilot chat windows and related controls within Visual Studio Code. I have Visual Studio Code open in front of me, displaying a simple web application that consists of an HTML file with associated images, scripts, and styles. This basic project will help us explore Copilot's interface elements and how they integrate with your development environment. One of the most important ways to interact with GitHub Copilot is through the chat window. To access this, you'll notice an icon in the top right area of VS Code's interface, next to the search bar. When I hover over this icon, a tooltip appears that says Toggle Chat. This is our gateway to Copilot's chat functionality. Let's take a closer look at this icon. Notice that it has a small drop-down arrow beside it. When I click on this arrow, it reveals several options for interacting with Copilot. The first option, Open Chat, is what we currently have active, so selecting it again wouldn't change anything. The second option is Editor Inline Chat. This powerful feature opens an inline chat window directly where your cursor is positioned in your code. My cursor is currently in the index.html file on line 9. If I select Editor Inline Chat, Copilot opens a text input field right at that line, allowing me to interact with Copilot referencing that specific piece of code. To dismiss the inline chat, I simply place my cursor in another part of the file and press the Escape key, and the inline chat disappears. Let's return to the drop-down menu by clicking on the Copilot icon again. The next option available is Quick Chat. When I select this, notice that it opens a streamlined query bar at the top of the IDE. This provides a more compact interface for quick questions without opening the full chat panel. To remove this quick chat bar, I can simply click the X button next to the bar itself. There are also two more options in this drop-down: Configure Code Completions and Manage Copilot. These are more advanced features that we'll explore them later in the course as we progress. Now, let's focus on the main chat window interface. I've closed the HTML file I had open, and you'll notice it no longer appears in the Chat Context section in the bottom right corner of VS Code. In the chat interface, notice the Add Context button. This allows us to provide additional files or information to Copilot to help it generate more relevant responses. By default, we're in Ask Copilot mode, which is indicated at the top of the chat window. Let me demonstrate how context affects Copilot's responses. Without adding any context, I'll type, add a hello world alert, and press enter. Since no files are currently open in my editor, Copilot provides a general response with a code snippet showing how to create a hello world alert in JavaScript, suggesting I could insert it into an HTML file. Now, let's try using the Add Context feature. When I click this button, I see various options appear below the VS Code search bar. If I scroll down, I can see all the files in my project. I'll select the scripts.js file to give Copilot that context. Now, when I ask the same question, add a hello world alert, and press enter, Copilot's response is much more specific. It suggests adding the alert directly to my scripts.js file, tailoring its response to the specific context I provided. Next, let's look at the symbol at the bottom of the chat window. When I hover over this, it shows Chat with Extension. This feature allows Copilot to interact with other VS Code extensions. If I click on it, I can see several default extensions already available, such as the terminal extension. Let me demonstrate how this works. I'll select the @terminal extension and then type, add a new file called about.html, and press enter. Copilot now knows I want to perform this action in the terminal. In its response, there's a button that says Insert into Terminal. When I click this button, the command to create a new file is inserted directly into my terminal window. I can then press enter in the terminal, and just like that, a new file called about.html is created in my project. Moving from left to right in the chat interface, we have the voice chat icon, which is self-explanatory. Clicking it allows you to speak to Copilot using your microphone instead of typing. Next to the microphone is a drop-down menu for different Copilot modes. By default, we're in Ask mode, but if I click the drop-down arrow, I can see two other options, Edit and Agent modes. Edit mode is designed for fast, precise code tweaks like refactoring a function, fixing a bug, or applying consistent changes across several files without having to manually open each one. Agent mode is the latest addition to Copilot, and its power comes from analyzing your entire codebase. You can use it for more significant architectural changes or even to run terminal commands. While edit mode focuses on specific code blocks, agent mode takes a project-wide approach. It's worth noting that in recent updates, I've seen edit and agent modes working together, suggesting that in future versions, these modes might be combined into a more integrated experience. Moving further right, we have a drop-down menu for selecting different language models to power Copilot. There are 4 different models available, with additional advanced options below. These options let you experiment with various large language models depending on your needs. Generally, models with mini in their name are lightweight versions, so you shouldn't expect the same capabilities as from the other 3 more powerful models, which are better suited for complex tasks requiring greater efficiency. It must be noted that the icons inside of the chat interface will change based on which model or mode you choose. This chat interface will be your main point of interaction when using Copilot in your daily development work. In our next demonstrations, we'll explore how to use these features to enhance your coding efficiency and solve typical development problems. In this demonstration, we're going to explore GitHub Copilot's code completion and code suggestion capabilities. These features are at the heart of what makes Copilot such a powerful tool for developers. Code suggestions in Copilot are generated based on several factors, including comments that you write in your code and your personal coding style. Recently, GitHub has enhanced this capability with a new feature called Next Edit, which we'll also explore today. I have Visual Studio Code open in front of me, displaying a simple web-based application. This project includes an HTML file, a JavaScript file named script.js, an image, and a style sheet. This will give us a good foundation to demonstrate Copilot's code completion features. At the top of the VS Code interface, on the right side of the search bar, you'll notice an icon for GitHub Copilot. When I hover over it, a tooltip appears saying Toggle Chat. I'm using the basic version of GitHub Copilot here, not a paid version with additional features. If I click on the drop-down arrow next to the Copilot icon, I get access to several options, including Configure Code Completions. In this basic version, clicking on this option only allows me to change the completion model itself. When I select Change Completions Model, I can see I only have the default option available. More advanced GitHub Copilot versions would offer additional model choices here. There's one more setting related to code completions that would normally appear in the bottom right corner of the IDE, but it's not visible on my current screen due to size constraints. This setting toggles the Next Edit feature, one of the latest additions to GitHub Copilot. Now, let's see how code suggestions work in practice. I have my scripts.js file open, and I'll start by adding a comment on line 1. I'll type // this file contains a simple calculator. As soon as I finish typing, you'll notice that Copilot offers a suggestion in italicized text. This is called ghost text. For now, I'll ignore that suggestion by pressing Enter and then Escape to clear it. Now, on line 2, I'll start writing a function. Watch what happens as I begin typing. Immediately, Copilot suggests that I might want to create a function called add. I'll accept this suggestion by pressing the Tab key on my keyboard. I'll continue pressing Tab to accept more of Copilot's suggestions, but now it's offering something I don't quite want, so I'll press Escape to reject it. I'll press Enter again to move to a new line, but Copilot's still not giving me exactly what I want. Let's look at something interesting happening here, though. Do you see that arrow pointing to the right? It is on line 2. That's the Next Edit feature in action. The Next Edit feature is suggesting that I might want to add parameters to my function and return their sum. This is a contextual suggestion based on what Copilot thinks I'm trying to do. I'll accept this Next Edit suggestion by pressing Tab. Immediately after that, Copilot suggests additional calculator functions like subtract, multiply, and so on. I don't want to accept all of these, so I'll press Escape. But it's now suggesting a subtract function. This isn't what I want right now, so I'll press Escape again. Let me go back to line 2 and add my own touch to this function. Instead of just add, I'll rename it to add numbers. Watch how Copilot adapts to this change. I'll finish line 4 with a semicolon and press Enter. Something changed. On line 5, instead of suggesting subtract as it did before, Copilot now suggests subtract numbers. This demonstrates how Copilot learns from code patterns. It noticed that I added numbers to my add function name, so it applies the same pattern to the subtract function. I'll accept this suggestion by pressing Tab, but I'll stop there by pressing Escape. Now, let's test our add numbers function. I'll type log on a new line, and VS Code offers its built-in shortcut for console.log. However, notice that the italicized text is a suggestion from GitHub Copilot, not VS Code. To accept Copilot's suggestion, I'll press Tab. Copilot even suggests what the output should be as a comment. I don't need anything else right now, so I'll press Escape. To summarize what we've done so far, Copilot offers code suggestions based on comments, adapts to your coding style and patterns, and provides Next Edit suggestions for further enhancements to your code. Let me demonstrate the Next Edit feature one more time. I'll go back to the add numbers function on line 2 and add a third parameter, c. Immediately, Next Edit suggests that I should add this parameter to the sum in the return statement. I'll accept this by clicking on the icon. Perfect. The function has been updated. Notice that Next Edit is also suggesting I should change the subtract numbers function on line 5. This may not be what you want, so you can either accept the suggestion or press Escape to ignore it, as I'll do now. This demonstration has shown you how to recognize and work with code suggestions in GitHub Copilot, how Copilot adapts to your coding patterns, and how the Next Edit feature can help you make consistent changes throughout your code. These capabilities can significantly speed up your development process and help maintain consistency in your code base. In this demonstration, we will continue exploring GitHub Copilot's code suggestion capabilities, but we'll focus on more advanced aspects. We'll examine how to refine the prompts we send to the language model, manipulate context to get more relevant suggestions, and explore multiple suggestion alternatives offered by GitHub Copilot. I have Visual Studio Code open on my screen with my project loaded. This is a simple HTML-based project containing an HTML file, a scripts.js JavaScript file, a CSS style guide, and an image. Currently, there isn't much content in either the index.html or the JavaScript file. In fact, the JavaScript file is completely empty. Let's start by exploring how we can refine prompts to get exactly the code we need. I'll open the chat window, and the scripts.js file is the only current file listed, and it provides the only context that Copilot has at the moment. Remember, this file is empty. I'm going to pass a simple prompt to the language model by asking Copilot to add numbers in a function. That's it, just this basic natural language request. I'll press enter and wait for Copilot's suggestion. As expected, Copilot has responded with a function called addNumbers that takes two parameters and returns their sum. It has also included a console.log statement to test the function. This might be exactly what you want, but let's try to refine this suggestion. I'll go back to the chat window and use the up arrow on my keyboard to retrieve my previous prompt. Now I can refine it by adding more specific requirements. I'll add the words using a lambda expression to my original prompt and press enter. Copilot is thinking about my amended request, and now it has returned a different implementation that uses a lambda expression as I requested. The function looks quite different from the first suggestion, demonstrating how refining your prompt can dramatically change the code Copilot generates. Above the response, there are a few icons. When I hover over the leftmost icon, it says Apply to scripts.js. When I click this icon, the entire block of code will be added to my scripts.js file. Let's refine our prompt even further. I'll use the up arrow again to retrieve my previous prompt and modify it once more. This time, I'll ask to add any amount of numbers in a function using lambda expression. This should give us something that can handle a variable number of arguments. I'll press enter to see Copilot's response. Copilot has now returned a more flexible function that can handle an array of numbers. I'll add this to the scripts.js file, and it has replaced the previous function. Let me close the Explorer window so we can see this function more clearly. The function now uses an array and the reduce method to sum up any number of values passed to it. Copilot has even provided an example showing how to call this function with an array of numbers 5, 3, 2, and 10, which should output 20. Next, I want to demonstrate context manipulation. I'll return to my original project, removing all code from the scripts.js file and starting a new chat window. Now I'm going to add a new HTML file to the project folder using the Explorer window in VS Code. I've added a file called calculator.html. When I open it, it looks similar to index.html, but has a form starting on line 24 and ending on line 33. This form includes 3 input fields and a couple of on-click events that call functions named calculateSum and calculateDifference. I'll keep this file open and go back to my empty scripts.js file. What I'm going to do now is drag the calculator.html file into the chat window area. This gives the chat the ability to see 2 files that are part of the project. Now I'll ask Copilot to add a function to sum up 3 values. I won't provide any additional context. Let's see what Copilot comes up with based on the calculator.html file I've dragged into the chat. Copilot is thinking about my prompt, and it has returned a calculateSum function. This implementation is quite different from our previous examples. I'll transfer this code to the scripts.js file and close the Explorer window so we can see it better. Consider what happened. Because we provided the calculator.html file as context, Copilot recognized that there are 3 form fields labeled num1, num2, and num3. The calculateSum function it generated is specifically designed to work with these field IDs from our HTML form. This demonstrates how providing context can dramatically improve the relevance of Copilot's suggestions. For the final part of this demonstration, I'll get Copilot to offer multiple suggestions based on context. My scripts.js file now has 3 functions: add numbers, subtract numbers, and multiply numbers, written in 3 different styles. I want to add a 4th function to divide numbers. Let's find out which style GitHub Copilot offers first. I'll position my cursor after line 9 and press enter. Copilot is offering a suggestion, but I'll ignore it by pressing Escape. Instead, I'll add a comment, function to divide two numbers. Copilot is offering the same suggestion again. But now, if I hover over the divide function name, I now have multiple options to choose from. I'll click on the arrows to navigate through the different suggestions. As I cycle through them, you can see that Copilot is offering different implementation styles for the divide function. While the last two suggestions appear similar, I have at least two distinct styles to choose from. This demonstrates Copilot's ability to provide multiple suggestion alternatives, allowing you to select the one that best matches your needs or coding style. These advanced techniques, refining prompts, manipulating context, and exploring multiple suggestion alternatives, give you much greater control over the code that GitHub Copilot generates, helping you get exactly what you need for your specific development tasks. In this demonstration, we're going to explore some of the settings available for GitHub Copilot that allow you to customize its behavior. What I have open on my screen is Visual Studio Code with GitHub Copilot installed as an extension. The application you see is a simple website that I've been using throughout this course. In the VS Code interface, there are two places where GitHub Copilot icons appear. One is at the top menu area, next to the search window. If I click on this GitHub icon, I can access options like Configure Code Completions or Manage Copilot, though the latter will take you to an external website on github.com. I'll close this menu for now. The second place is at the bottom of the screen, almost like a taskbar. If I hover over the Copilot icon here, you'll see several settings that we can adjust. But what I want to focus on in this demonstration is how to access and modify the full range of Copilot settings. To do this, I'll go to the left admin bar of VS Code where the cogwheel icon is located. When I hover over this icon, the tooltip responds with Manage. Clicking on this icon will take us to the settings for VS Code. Once the Settings tab opens, it displays all the settings available for VS Code. To find GitHub Copilot's specific settings, I need to type GitHub in the search bar. This filters the settings to show only those related to GitHub. To narrow it down further, I'll add Copilot to my search. Now it displays all the settings that specifically pertain to GitHub Copilot. One thing to note here is the settings.json file listed just below the search bar, but that's a more advanced topic that we won't cover in this demonstration. As I scroll down through the GitHub Copilot settings, there are quite a few options we can customize. For this demonstration, I'm going to focus on the follow-ups setting. But before we dive into that, let me point out a few other interesting settings. If I continue scrolling, one option is that we can override the local language. Currently, English is the default, but you can switch to other languages like French or Italian, depending on what's available at the time you are consuming this demonstration. Scrolling down further, there is a setting called Terminal Chat Location. This determines where responses to terminal queries appear. The default is Chat View, which means when you ask a query like, "How do I add a file using the terminal window?" the response will appear in the chat window. Alternatively, you can configure this setting to send responses directly to the terminal window. For now, I'll leave it at the default setting. Now, let's go back to the follow-ups setting. The default for this setting is actually first only, but I've changed it to never to demonstrate the difference. Let's close the Settings tab and check how this affects Copilot's behavior. I'll go back to the VS Code interface and drag the calculator.html file into the context area of the chat. Then, I'll ask Copilot to add a function to the script.js file that will comply with the calculate sum function in the HTML file. I'll press Enter to submit this query. GitHub Copilot examines my query, looks at the calculate sum function, and determines that I want to add a function that sums three numbers, as defined in the HTML form. As I scroll down through the response, Copilot provides information about the function and mentions a similar code found with one license type, which I could explore if interested. But the response ends here. There are no follow-up questions or suggestions. Now, let's change the setting and check the difference. I'll right-click in the chat window and add a new chat. Then I'll go back to the settings and change the follow-ups setting from never back to the default first only. After closing the Settings tab, I'll return to the scripts.js file, expand the chat window, and ask the same question again using the up arrow on my keyboard to recall my previous query. When Copilot responds this time, the initial answer looks similar. But if I scroll down past the information about the function, there is an additional section that states, how do I link this function? This follow-up information wasn't present when I had turned off follow-ups. By enabling the first-only option, Copilot now provides additional context and guidance after answering my initial question. The settings you can modify in GitHub Copilot within Visual Studio Code will depend on the licensing version you have. In this demonstration, I'm using the corporate version, which provides access to these customization options. By exploring and adjusting these settings, you can tailor GitHub Copilot's behavior to better match your workflow and preferences, making it an even more powerful tool for your development tasks. GitHub currently offers 3 Copilot plans tailored for individual developers. These plans are designed to accommodate different needs based on your coding habits, interest in AI models, and desired level of flexibility. All individual plans share certain core capabilities. Each allows you to generate code completions and use Copilot chat to get assistance with your coding questions. They also support command line requests, enabling you to interact with Copilot directly from your terminal. Let's start with the GitHub Copilot free version, which is perfect for individuals who want to test the platform before committing to a purchase. This entry-level option gives you a taste of AI-assisted coding without any financial investment. However, the free plan does come with significant limitations. Subscribers are restricted to 2,000 code completions per month when used with an integrated development environment, and only 50 total chat requests per month in Copilot chat. These constraints are designed to give you enough access to evaluate the tool while encouraging power users to upgrade to paid tiers. Moving up to Copilot Pro removes some of these restrictions, providing unlimited code requests for more intensive development work. While standard requests are unlimited, premium requests that involve interaction with more powerful models like GPT 4.5 or clients on it are limited to 300 per month. These advanced models can handle more complex queries and provide more sophisticated assistance for challenging coding tasks. For developers who find themselves regularly maxing out their premium request quota, GitHub offers Copilot Pro Plus. This enhanced tier increases the premium request limit to 1,500 per month, 5 times the standard Pro allowance, and may provide access to additional powerful models as they become available. This makes Pro Plus ideal for developers working on complex projects that require frequent interaction with Copilot's most advanced capabilities. Understanding these options allows you to select the plan that best matches your development needs and budget constraints. In the following demonstration, we'll see how the individual version of GitHub Copilot works in practice, exploring its interface and capabilities within Visual Studio Code. I have just opened Visual Studio Code and imported a simple TypeScript project to work with. The individual version of GitHub Copilot provides access to all of Copilot's core features. You can interact with GitHub Copilot in several ways: through inline chat directly in your code, through the regular chat window for broader queries, and you have access to various large language models. You can also change the operational mode of Copilot and interact with the terminal window using GitHub Copilot Chat. As an individual user, one of the most convenient ways to interact with Copilot is through its inline chat feature. Let me demonstrate this by highlighting a function in my code. I'll select this entire compound interest function, then press Ctrl+I on my keyboard to activate inline chat. Now I can ask Copilot about this specific section of the code. Let me type a question. What does this function do? Even though there's a slight misspelling in my question, GitHub Copilot understands what I'm asking and analyzes the highlighted function. It's now providing detailed information about the compound interest calculation. If I wanted to, I could take this information and use it as documentation for my code. Let me close this chat window and show you another way to interact with GitHub Copilot. We can use the main chat window, which gives us access to a broader range of capabilities. If you don't see the chat window open, you can access it by clicking on the GitHub Copilot icon at the very top of your IDE, next to the search bar. Clicking this icon toggles the GitHub Copilot chat window on or off. As you can see, GitHub Copilot is fully integrated into Visual Studio Code as an extension. You also have access to the chat window at the bottom of the screen in this window. Here, you can ask various questions and chat with different extensions. For example, I currently have the @terminal extension open, which means that any questions I ask will reference the terminal window, not the code I'm writing. We can also change the operational mode of GitHub Copilot. Instead of the default Ask mode, we can switch to Edit or Agent mode for different types of assistance. Additionally, we can change which large language model we're using. For instance, I could switch to Claude 3.7 Sonnet for certain tasks. As you can see, individual users have full access to the chat window and all of its features. Now, individual users may want to check their profile settings and subscription details. To access this information, you can click on the chat icon next to the search bar, open the drop-down menu, and select Manage Copilot. This opens a browser window that takes you directly to the GitHub Copilot section of your GitHub account on github.com. I'm currently using the free version, which limits me to 2,000 code completions and 50 chat messages per month. If I wanted more information about my subscription, I could navigate to the Billing and Licensing section in the sidebar, then click on Overview. This shows my current metered usage and included allowances. I can click on More Details to see a list of all the features and limitations of my current account. If I close that and go to the Usage section, I get a more direct indication of my current usage. Since I haven't used this account much yet, there's nothing showing in the usage area. But this is where you would find detailed information about your account usage, and you can even generate usage reports. Let me explain the other versions available within the individual tier. The Pro version is for developers who want more flexibility, including unlimited completions and access to additional large language models. This version includes unlimited code completions in the IDE, full access to chat, additional LLMs, 300 premium requests involving agent mode, code review, and Copilot extensions. This is the version offered to the academic sector. Copilot Pro Plus is for power users who want the best performance and most model access. This version has everything that the free and pro versions have, plus a lot more access to advanced features. This level has full access to all LLMs that Copilot currently has. Maximum of 1,500 premium requests with the ability to pay as you go for additional requests. Priority access to advanced AI capabilities as they become available. In this demonstration, we will do a quick dive into some of the enterprise features of GitHub and GitHub Copilot. We'll begin by exploring a new feature of GitHub Copilot that allows organizations and businesses to access the REST APIs directly. Then we'll look at file exclusions, which provide control over what content Copilot must ignore. Finally, we'll examine the logging details that Copilot maintains for auditing purposes. I want to note that the APIs we'll be discussing are still in an experimental stage and may have changed by the time you watch this demonstration video. With that said, let's begin with accessing those REST APIs. Before we can do anything else, we must authenticate with GitHub. I'm using the terminal window in Windows, and I'll be working with the GitHub Copilot CLI. You could also use curl if you're familiar with that tool, or plain JavaScript to perform similar tasks. The first command I'll enter in the CLI is auth-login. After pressing enter, I'm prompted to specify where I want to use GitHub. I'll select github.com and then choose HTTPS when asked if I want to use HTTPS or SSH. Next, I'm asked if I want to use my credentials, and I'll confirm by typing Y for yes. Now I'm prompted to log in with a web browser, and I'll be given a one-time code. I'll press enter where the arrow is indicating login with a browser on the terminal. The system has now generated a one-time code for me. I'll copy this code using Ctrl+C, as I'll need to paste it in the next step. After pressing enter, my browser opens to a device activation page. I'll click Continue here, and this is where I'll paste the one-time code I just copied. After pasting the code, I'll click Continue again. Now I'm being shown specifically which access features I'm granting to GitHub and GitHub Copilot. I'll authorize GitHub by clicking the authorization button, giving me access to the various parts of Copilot we need to demonstrate. Now that I'm authenticated, I can return to the terminal window and perform RESTful requests. I'll enter the command ghapi/user, which asks the system for information about the current user. After pressing enter, we can see detailed information about the authenticated user. If I scroll up a bit, you can see that the logged-in user is Axbaring, along with other user details. Let's switch our focus now to github.com, where I'll demonstrate some of the business-level features available through the web interface. On github.com, I've created two organizations, a parent organization and a member organization. This structure represents an enterprise-level setup where you might have multiple teams or divisions under a main corporate entity. One of the key features I want to demonstrate is how to exclude specific files from GitHub Copilot. This is important when you have sensitive information that you don't want Copilot to analyze or reference when generating suggestions. In this demonstration company I've created on github.com, you can see I have one repository. Clicking on Repositories shows a demo repository. When I open this repository, there are several files, including a secrets.json file. This is the file I want to exclude from Copilot searches. To set up this exclusion, I'll go to my profile image and click on it, then select your Copilot. However, when I navigate to the Copilot section, I don't see any options under Copilot for my personal account. I need to scroll down and switch to AB Demos Incorporated, the organization account, and manage the settings there. After switching contexts, I now have more options available, including content exclusion. Remember that this other organization, AB Demos Incorporated, is the parent company that owns Axbaring. I'll click on Content Exclusion to configure which files should be excluded from Copilot analysis. Now, I have the ability to add files that I want to exclude within this text area. The file I want to exclude is that secrets.json file we saw earlier. There's a specific format required when adding files to this exclusion list. As you can see, I've added a comment to let anyone else who has access to this configuration know what I'm doing. The comment says, ignore a file called secret.json. To properly exclude a file, I need to enter the information as key value pairs. First, I add a key, which in this case is secrets on line 2. Then below that, I add the actual file information, starting with a dash and then the path to the file in double quotation marks. It's important to follow this specific format, the category name on the first line, then a dash on the next line directly below, followed by the file path in quotation marks. Once I've entered everything correctly, I can click the Save Changes button in the bottom right corner of the browser. After saving, I get a green confirmation message, successfully updated excluded paths. Now this secrets file will be ignored in any future Copilot searches, ensuring sensitive information remains protected. While we're in this section of the website, let's scroll all the way down to examine another important feature. Under the Archive section in the sidebar, there's a Logs option. Clicking on Logs brings up the audit log, which shows all activity that has occurred on this account since it was created. You can export this audit log to CSV or JSON format, giving you comprehensive access to all activity that has taken place within your account. This audit capability is crucial for enterprise environments where tracking and accountability are important. This demonstration has shown you how business-level subscribers can access GitHub's APIs, exclude sensitive files from Copilot analysis, and maintain detailed audit logs for security and compliance purposes. These features provide the control and oversight that organizations need when implementing AI-assisted development tools across their teams. In this demonstration, we're going to set up a knowledge base in GitHub Copilot. It's important to note that you need the enterprise version or enterprise level of service to add a knowledge base, as this is one of the premium features reserved for higher-tier subscriptions. What I have on my screen is a web browser open to github.com. I'm logged into my profile, and I'll start by clicking on my profile logo in the top right corner, then selecting Your Repositories. Here we can see I have a repository called JS Style. This repository contains a style guide for JavaScript that I want to make available through GitHub Copilot. The intention is to ensure that this style guide is accessible to my entire organization and its members when they're using Copilot, helping maintain consistent coding standards. I'll click on the repository to open it, then navigate to the CSS in JavaScript folder. Inside this folder, we can see a README file. When I scroll down through this file, you'll notice it's from a popular website. I've borrowed this public content just for demonstration purposes. If we continue scrolling, we can see examples showing the difference between bad naming conventions and good naming conventions for JavaScript. This is exactly the type of guidance we want to capture in our knowledge base to ensure coding consistency throughout our organization. Now I'll scroll back up and click on my profile logo again. This time, I'll select your Copilot to access my Copilot settings. When the page loads, I'll look at the left side of the browser window and scroll down in the sidebar until I find the Copilot option. At the moment, I can't do much with Copilot at this level. I only see a few basic settings because I'm viewing my personal member account. To access more advanced features, I need to switch context to the parent account or enterprise level. I'll click on Switch Settings Context near the top left part of the web browser and select my parent company, which is AB Demos Incorporated. After selecting this, I'll scroll down to the Copilot section again. Now, notice that I have a drop-down arrow next to Copilot. When I click on this drop-down, I can see additional options, including knowledge bases, custom instructions, and more. These options aren't available at the individual user level. I'll click on Knowledge Bases, which gives me the ability to add a new knowledge base to my organization. Before I can do this, I need to make sure my repository is properly set up. I'll go back to the top of the browser window, just beneath my organization name, AB Demos Incorporated, and click on Repositories. Here I can see our JS style repository again, confirming that I've imported it into the parent company. Now, I need to configure this repository to be properly accessible as a knowledge base. I'll click on the JS style repository, then click on the settings icon, the cogwheel. This takes me to the general settings area for the repository. What I'm looking for is the Pages section, so I'll scroll down the left sidebar until I find it near the bottom and click on it. In the Pages section, I need to make sure the repository is configured correctly. I can see I have two options here. First, I need to make sure Deploy from a branch is selected. Next, I need to configure which branch to use. I'll click on the drop-down where it currently says None and select Master, since that's the main branch for this repository. This ensures the repository content is properly accessible for the knowledge base. With the repository now configured, I can return to setting up the knowledge base. I'll click on my profile picture again, select your Copilot, and then need to switch back to the parent company context. I'll click on Switch Settings Context again and select AB Demos Incorporated as the parent company. Now I'll scroll down to Copilot, click on the drop-down arrow, and select Knowledge Bases. Here I can click on the New Knowledge Base button in the middle of the page. This opens a form where I can create my new knowledge base. First, I'll give my knowledge base a name, JS Styles. I could also add a description if I wanted to provide more context. Then I'll scroll down to the Add Repositories section and click on the Add Repositories button. This opens a pop-up where I can select which repositories to include in this knowledge base. I'll click on AB Demos Incorporated /JS style to select it, then click the Apply button in the pop-up. The final step is to click the Create Knowledge Base button at the bottom of the page. When I do this, GitHub will index the repository content, making it searchable and accessible through Copilot. Once the indexing is complete, we have a fully indexed knowledge base that Copilot can use to provide style-compliant suggestions. With this knowledge base configured, developers in our organization will now receive code suggestions from Copilot that align with our JavaScript style guide, helping maintain consistency across all our projects. This demonstrates the powerful customization capabilities available exclusively at the enterprise level of GitHub Copilot. In this demonstration, I'm going to show you 3 high-value use cases where GitHub Copilot Chat can significantly enhance your development process. While Copilot assists developers in many ways, such as automating repetitive tasks, providing real-time code suggestions, enhancing code quality, and creating learning opportunities, we'll focus on 3 specific scenarios that showcase its power. Let's start with our first use case, using GitHub Copilot to initialize a new project. This is particularly valuable when you're starting from scratch and need to quickly establish a project structure. I have Visual Studio Code open on my screen with no projects currently loaded. To begin, I'll access GitHub Copilot Chat by clicking on the chat icon located in the top right corner of VS Code, next to the search bar. This opens the chat panel on the right side of my IDE. In the chat input field at the bottom of this panel, I'll type a simple request. I want to create a TypeScript project with Webpack support. This natural language prompt tells Copilot exactly what I need without requiring me to know the specific setup steps. I'll press Enter to send this request to Copilot. Copilot is now responding with a proposed directory structure for a TypeScript project. Notice that since I don't have a project open yet, Copilot is offering a Create Workspace button within its response. This is an interactive element that will help us set up the project. When I click on this Create Workspace button, my operating system's File Explorer opens, allowing me to select where I want to create this project. I'll navigate to my Documents folder, then to my Projects directory, and select it as the parent folder for this new project. After clicking Select as Parent, in the Windows pop-up, GitHub Copilot begins creating an entire project structure for me. It's generating all the necessary folders and files for a TypeScript project with Webpack support. Once complete, Copilot asks if I would like to open the created workspace. I'll click Yes to open it. Visual Studio Code now displays our newly created project. Notice that Copilot has generated a complete project structure, including a source folder and all the configuration files needed for a TypeScript project with Webpack support. This demonstrates how Copilot can rapidly bootstrap a project without requiring you to manually create files or remember configuration details. For our second use case, let's see how Copilot can help us create and populate files with specific content. I'll first open the terminal by clicking on the ellipses at the top of VS Code, hovering over Terminal, and selecting New Terminal. This opens a terminal panel at the bottom of my screen. I'll also make sure the Copilot chat panel is open by clicking on the Copilot icon at the top of VS Code. In the chat input field, I'll type, create a new file in the project folder called db.json. After sending this request, Copilot offers to create the file for me. I'll click on the Create File button in its response, which opens a Save dialog. I'll click Save File to confirm, and now we have a db.json file in our project. I notice that this file already contains some default JSON content, but that's not exactly what I want. I'll erase this content and return to the Copilot chat panel to request more specific content. In the chat input field, I'll type, create an employees array consisting of 3 sample employee objects, each with a username, an email, and a password, inside of the db.json file you just created. Copilot responds with a complete JSON structure containing an employees array with 3 sample objects, each having the requested properties. To apply this to our db.json file, I'll click on the icon at the top of Copilot's response that says Apply to db.json when I hover over it. Immediately, the employees array with 3 properly formatted objects is inserted into my db.json file. I'll click Keep to confirm this change. Just like that, I've created and populated a data file without writing a single line of code myself. For our third use case, let's see how Copilot can provide implementation guidance. Since we've created a JSON file with employee data, I'll ask Copilot how to serve this data through a mock server. I'll return to the Copilot chat panel and type, how can I serve this employee object using a mock server? Copilot responds with comprehensive instructions for setting up a mock server using JSON Server. It explains how to install JSON server using npm, how to start the server to monitor our db.json file, and even provides examples of how to access, create, update, and delete employees through HTTP requests to the local server. These detailed instructions include the exact commands I need to run in the terminal and the URLs I would use to access different endpoints. This guidance allows me to quickly implement a working mock API without having to research the proper approach or remember specific commands. These three examples demonstrate how GitHub Copilot Chat can dramatically accelerate your development workflow by 1. Bootstrapping entire projects with proper structure and configuration. 2. Creating and populating files with specific content tailored to your needs. 3. Providing implementation guidance for common development tasks. By leveraging these capabilities, you can focus more on solving unique problems in your application rather than spending time on boilerplate setup and standard implementations. In this demonstration, I'll show you techniques to improve the responses you get from GitHub Copilot and strategies for working around some of its limitations. There are several approaches we can use to enhance Copilot's performance, which fall into two main categories. The first category involves adjustments to your development environment, which is what we're looking at today in Visual Studio Code. The second category focuses on developer strategies, such as iterating over prompts, providing context, and prompt engineering techniques, which we'll explore in future demonstrations and videos. Today, I want to focus on a specific environment change that can significantly improve your Copilot experience, adding a special instructions file. While there are other environment tweaks available, like blocking public code, adding to the knowledge base, or removing language models if you have extras, the instructions file is particularly powerful for tailoring Copilot's output to your preferences. I have Visual Studio Code open on my screen, displaying a simple TypeScript project that we used in a previous demonstration. To begin, I'll ask Copilot to create a basic function for us to establish a baseline for its default behavior. In the Copilot chat panel on the right side of my screen, I'll type, "Give me a simple function that will accept volts and current and return watts." I'll press enter to send this request. Copilot responds with a straightforward function that calculates watts by multiplying volts and current. To add this to our project, I'll click on the leftmost icon at the top of Copilot's response window. When I hover over the icon, it says Apply to src/index.ts. The code is now inserted into our index.ts file. Scrolling down, we can see that Copilot has provided both the function definition and an example of how to use it. This might be exactly what you need in many cases. However, there's a limitation here. This function doesn't handle edge cases like negative input values or other invalid inputs. Copilot does not always account for input validation or edge cases unless specifically prompted. Notice that on the right side of Copilot's response, there's a follow-up question: how do I handle invalid inputs? If I click on this, Copilot provides suggestions for handling negative values or potential division by zero situations. This built-in follow-up feature is one way Copilot helps address its own limitations. Now, let's look at how we can customize Copilot's behavior using an instructions file. I'll move to the left side of VS Code where the Explorer panel shows our project files. Making sure I'm in the root of the project, I'll click on the New Folder icon and create a folder with a specific name, .github. That's a dot followed by GitHub. This hidden folder is where Copilot will look for special instructions. Within this new folder, I'll create a file by clicking the New File icon in VS Code. This file must be named exactly copilot-instructions.md for Copilot to recognize it. After typing this name and pressing enter, VS Code opens the new file for editing. In this file, I'll add a simple instruction. We always add an underscore to each variable name. This single line will instruct Copilot to follow this naming convention in all code it generates for this project. I'll save and close this file. Now, let's remove our previous function and ask Copilot for the same function again to see how its behavior changes. I'll delete the existing function from the index.ts file, then return to the Copilot chat panel. Using the up arrow key on my keyboard, I'll recall my previous request. Give me a simple function that will accept volts and current but return watts. I'll press enter to send this again. This time, notice how Copilot's response is different. The function it generates now uses variable names with underscores, underscore volts, and underscore current, instead of just volts and current. I'll apply this to our index.ts file by clicking on the leftmost icon at the top of Copilot's response. Looking at the code in our editor, we can confirm that Copilot has followed our instruction by adding underscores to all variable names. This demonstrates how a simple instruction file can influence Copilot's output to match your team's coding standards or personal preferences. This technique is particularly valuable in team environments where consistent code style is important. By adding the copilot-instructions.md file to your repository, you ensure that all team members receive Copilot suggestions that follow your team's established conventions, even if they don't explicitly request them in each prompt. In addition to naming conventions, the instructions file can specify other preferences like code formatting standards, documentation requirements, error handling approaches, testing conventions, and other project-specific guidelines. This approach allows you to work around one of Copilot's limitations, its default tendency to generate generalized code, by customizing its output to match your specific requirements without having to repeat these preferences in every prompt. By combining environment tweaks like the instructions file with effective prompting strategies, you can significantly enhance the relevance and usefulness of GitHub Copilot suggestions while minimizing the need to modify its output manually. In this demonstration, I'm going to show you how to initiate the feedback process with GitHub Copilot using the chat window. This feedback process, often referred to as review, allows Copilot to analyze your code and offer improvement suggestions. What makes this capability powerful is that Copilot can review code you write directly within VS Code or from your GitHub repository on github.com. This means you can integrate code review into your normal workflow regardless of where you're working. I have Visual Studio Code open in front of me with a simple TypeScript project that we've used in previous demonstrations. I've added a function to the index.ts file, a compound interest calculation function, which we'll use to demonstrate Copilot's review capabilities. To have Copilot review this function, I'll first highlight it by clicking and dragging to select the entire function's code. With the code selected, I'll right-click to open the context menu. Notice that one of the options in this menu is Copilot. When I hover over this option, a submenu appears with several Copilot-specific actions. Scrolling down in this submenu, I see the option Review and Comment. I'll click on this option to get Copilot to analyze my code and provide feedback. Copilot is now reviewing the selected code. Its response appears in a panel that overlays the code editor. Interestingly, Copilot has recognized that I have a copilot-instructions.md file in my project, which we created in our previous demonstration, and it notices that my code doesn't follow the guidelines specified in that file. Specifically, it points out that I didn't follow the guideline of adding underscores to variable names. This demonstrates how Copilot integrates knowledge of your project's conventions into its review process. In the code editor, Copilot has provided inline suggestions for improvements. For each suggestion, I have options to either apply or discard the change, and I can navigate through multiple suggestions using the Go to Next button. I'll click Apply and go to Next for the first suggestion. Copilot is recommending that I return amount minus principal for clarity. I'll apply this suggestion as well. Scrolling back up through my code, I can see that Copilot has added underscores to the variable names, aligning with the instruction file we created earlier. However, I noticed that it added an underscore to the function name as well, which wasn't my intention. Since function names weren't meant to follow this convention, I'll manually remove that underscore. I also noticed that Copilot didn't add underscores to the parameters in the compound interest function. This is fine since these are parameters rather than internal variables, but it demonstrates that you may still need to make judgment calls about which suggestions to accept. Now, let's review another function I've added to the file. This function, called test compound interest, is designed to test the compound interest calculation function we just reviewed. I'll highlight this function, right-click on the highlighted code, navigate to Copilot in the context menu, and select Review and Comment again. Copilot is now analyzing this second function. In its review, it notes that the function name doesn't follow the provided guidelines, suggesting an underscore, but as we discussed, we don't want to apply this convention to function names. What's more valuable is the second suggestion. Copilot recommends adding a comment to explain that interest is being calculated, which would improve code readability. Returning to the code editor, I'll navigate through the suggestions. I'll discard the function name suggestion since we don't want to modify function names. For the second suggestion about adding a comment, I'll click Apply. Scrolling back to view the function, I can see that Copilot has added a helpful comment: calculated compound interest. This improves the code's readability and documents its purpose. While this example uses relatively simple code, it demonstrates the core workflow for getting feedback from Copilot. For more complex code bases, Copilot's review can identify potential bugs, performance issues, security vulnerabilities, and other concerns that might be harder to spot manually. The review process is particularly valuable because 1. It can identify inconsistencies between your code and project conventions. 2. It catches issues you might miss during initial development. 3. It suggests improvements that enhance readability and maintainability. 4. It serves as a learning tool by explaining best practices and reasoning behind suggestions. By integrating this review process into your development workflow, you can leverage Copilot not just for generating code, but for improving the quality of code you've already written. This creates a continuous feedback loop that helps you grow as a developer while maintaining higher code standards. In this demonstration, I'll show you how to use GitHub Copilot/commands, which are powerful shortcuts for performing specific tasks on your code. According to Microsoft and GitHub, /commands are specific actions that can be run against any part of your code or even your entire application. At the time of recording, there are about 8 such actions available with the / prefix, though this number may have increased by the time you're viewing this video. These commands provide quick access to Copilot's most useful functions. I have a previous TypeScript project open in VS Code. Let's begin with an easy command, the explain command. Looking at line number 8 in my code editor, there is a mathematical formula used for calculating compound interest. Even though this is a mathematical formula rather than programming logic, let's see if Copilot can explain it. I'll highlight this entire line, which is now line number 9 since I moved it down slightly. To invoke the inline chat feature, I'll press Ctrl+I on my keyboard. This opens a small chat interface directly in the code editor, right where my cursor is positioned. To access the /commands, I'll type a / character, which reveals a drop-down menu of available actions. In my basic version of GitHub Copilot, I see 6 options. I'll select Explain from this list and press Enter to select it. To send this command, I need to click the right arrow on the side of the inline chat window or press the keyboard shortcut to send and dispatch. After I do this, Copilot analyzes the selected code and provides an explanation. Looking at Copilot's response, I can see it has provided a detailed explanation. At the top, it states, the active selection is a mathematical expression commonly used to calculate compound interest. It then continues with a breakdown of all the components in the formula, explaining each part's purpose. This demonstrates that Copilot can explain more than just programming code. It can help with mathematical formulas and other expressions as well. I'll close this explanation window by clicking outside of it, which removes the highlighting from line 9. Now, let's look at the function that starts on line number 2. At first glance, there appear to be no errors in this function. There are no red squiggly lines indicating syntax errors. However, Let's use another slash command to check for other types of issues. I'll highlight the 4 variables from lines 3 to 6, then invoke the inline chat again with Ctrl+I. I'll type a / and select the fix command from the drop-down list. After pressing Enter and clicking the right arrow to dispatch the command, let's see what Copilot finds. Interestingly, while there are no syntax or logical errors, Copilot has identified that the code doesn't follow the naming convention specified in our Copilot instructions file, which we set up in a previous demonstration. It reminds me that our project convention requires adding an underscore to each variable name. I'll accept this suggestion, and now my code follows our established convention. I'll click outside the highlighted area to remove the selection. Another powerful / command is the test command. I'll highlight the entire function starting on line 2 and ending on line 11. Press Ctrl+I to bring up inline chat, type a / and select Test from the options. After sending this command, Copilot generates comprehensive test code for the selected function. Even though I haven't set up testing for this project, Copilot has provided all the code needed to thoroughly test each aspect of the function. This includes multiple test cases covering different scenarios. Since I don't have testing configured for this project, I won't accept this code, but this demonstrates how you can quickly generate tests for your functions. I'll close this suggestion by clicking on the ellipsis at the top and selecting Close All. Let's try another command. I'll highlight the same function again, press Ctrl+I, type a /, and this time select Doc from the options. The doc command generates documentation for the selected code. Copilot returns with comprehensive documentation for this function, stating that this function calculates compound interest earned on an investment. It also provides a detailed list of all parameters with explanations of each one. This documentation can be incorporated directly into your code as inline comments or used in external documentation. I'll accept this documentation suggestion, then click Away to remove the highlighting. Now, let's examine the Edit command. I've intentionally removed the underscore from the principal variable name to demonstrate this feature. I'll highlight lines 17 to 19, invoke inline chat with Ctrl+I, type a / and select Edit. After pressing Enter, I'll type the instruction, change principal to underscore principal. After pressing Enter again, Copilot not only makes the requested change, but also notices and fixes a spelling error I made in my instruction, correcting principal to principal. I'll accept this change, demonstrating how the Edit command can be used for targeted modifications to your code. One important thing to note is that we've been using the inline chat with / commands so far, but you can also use these commands in the main chat window. If I go to the chat panel and type a / in the Ask Copilot area, notice that I see many more options than were available in the inline chat. This expanded set of commands provides even more functionality when working in the main chat interface. To summarize, / commands provide quick access to Copilot's most powerful features directly within your workflow. Whether you need explanations, documentation, tests, or fixes, these commands help you leverage Copilot's capabilities without interrupting your coding process. By mastering these commands, you can significantly enhance your productivity and code quality with minimal effort. In this demonstration, I'm going to walk you through installing the GitHub Copilot CLI on a Windows 11 system. The GitHub Command Line Interface, or CLI, is a powerful tool that helps you perform GitHub-related tasks directly from your terminal, such as managing pull requests and other repository operations. The main advantage of installing the GitHub CLI is that you don't need to close your terminal window and switch to a different application to interact with GitHub. Using the CLI creates a more streamlined workflow for developers. GitHub has made the CLI intuitive to use by ensuring all commands start with GH, making them easy to remember and type. We'll begin with the Windows terminal window that comes with Windows 11. First, we'll utilize a package manager called winget, which is pre-installed on Windows 11 systems. In my terminal window, I'll type the command winget install id github.cli. Let me type this out carefully. Winget space install space --id space github.cli. I'll press enter to begin the installation process. The first thing I see is a prompt asking for my agreement to the terms. I'll type Y and press enter to accept these terms. The installation is now progressing. A Windows installer dialog has appeared, asking for permission to make changes to my system. I'll click the Yes button to continue. The terminal now shows a message indicating successful installation of the GitHub CLI. Next, we need to install the GitHub Copilot extension for the CLI. However, we'll use another package manager called Chocolatey for this step. In my terminal window, I'll type choco install gh. After pressing enter, I receive a message warning that Chocolatey has detected I'm not running from an elevated command shell, which might cause errors. Since we want to avoid potential issues, I'll type N for no, declining to continue with the current command. Instead, I'll close this command prompt and open a new one with administrator privileges. To do this, I'll go back to my Windows desktop, right-click on the command prompt icon, and select Run as Administrator. When prompted if I want to allow this app to make changes to my device, I'll click Yes to continue. Now in this administrator command prompt, I'll try running the same command again, choco install gh. After pressing enter, I'm asked if I want to run scripts, specifically the Chocolatey install PowerShell script. I'll type Y for yes and press enter to allow this. The installation process is now running, and it appears to have completed successfully. We now have both the GitHub CLI and the GitHub extension installed on our system. The next step is to install the GitHub Copilot extension for the CLI. To do this, I'll enter the command gh extension install github/gh copilot. Let me type this carefully. Gh space extension space install space github/gh copilot. I'll press enter to execute this command. I'm now being prompted to log in first before I can install the extension. Let's complete this authentication process. When asked where I use GitHub, I'll select github.com by typing this option and pressing enter. Next, I'm asked to choose between HTTPS or SSH for connecting to GitHub. I'll select SSH by typing this option and pressing enter. Now GitHub CLI is asking if I want to generate a new SSH key to add to my GitHub account. I'll type Y for yes and press enter. I'm now prompted to enter a passphrase for my new SSH key. I'll type my passphrase and press enter. For security reasons, you won't see the characters as I type. Next, I'm asked for a title for my SSH key. I'll enter Axel Stuff as the title and press enter. Now I'm asked how I would like to authenticate with the GitHub CLI. I'll choose to log in from a web browser by pressing enter to select this default option. The CLI is now providing me with a one-time code that I need to copy. I'll press Ctrl+C to copy this code. Next, I'll press enter as instructed to open the device login page in my web browser. The browser has opened to GitHub's device activation page. I'll continue as my user account Axbar by clicking on my profile. Now I need to enter the code I copied earlier. After pasting or typing the code, I'll click Continue. I'm now asked to authorize GitHub CLI by clicking the green Authorize GitHub button in the bottom right corner. I'll click this button to proceed. I'm prompted to sign in to confirm my identity. After signing in, I see a message. Congratulations, you're all set. I'll close the browser window and return to my terminal. Back in the terminal, I can see I'm now authenticated with GitHub CLI. To test this, let's try logging out with the command ghauth logout. After pressing enter, the system confirms I've been logged out, noting my account Axbar. For those who want to learn more about GitHub CLI commands, you can find comprehensive documentation at cli.github.com/manual. This resource lists all available commands and options for the GitHub CLI. With GitHub Copilot CLI now installed on your system, you can leverage its features directly from your terminal, streamlining your workflow and reducing the need to switch between different interfaces. The CLI integration with Copilot brings the power of AI assistance directly to your command line, making it accessible wherever you work within your development environment. In future demonstrations, we'll explore specific commands and use cases for the GitHub Copilot CLI that can further enhance your productivity as a developer. In this demonstration, we're going to pay attention to the chat window and specifically examine how chat history can be leveraged to maintain context and improve GitHub Copilot's outputs. What I have opened on the screen is Visual Studio Code, and I used GitHub Copilot to build this application. It's a very basic HTML-based application consisting of two HTML files, a script.js file, and a styles.css file. I have intentionally not cleared the chat history yet. I wanted to leave that conversation in the chat window so that we can ask questions based on our previous interactions and see how Copilot uses that historical context. Let me demonstrate this with a specific example. Here's a prompt that references our chat history. When you added the banner for the homepage, what color did you choose for the hover effect? I'll send that prompt now by typing it into the chat window and clicking on the arrow in the bottom right corner. When you hover over that arrow, it says Send and Dispatch. I'll click on it now. The prompt goes to the large language model, and we're waiting for the response. Here is the response. It's telling me that when the banner was created, the hover effect for the navigation links was set to a specific background color. The color was referenced as Skillsoft Orange. When I was building this website, I had asked GitHub Copilot to create a banner for me based on the colors of the Skillsoft.com website. This is why it's referencing that color as Skillsoft Orange. It remembers that context from our earlier conversation. Let's ask another prompt that builds on our history. Show me all of the prompts where the color was affected. I'll pass this over to the LLM and wait for the response. Here is our response. The answer is quite detailed, but it's basically pointing out 5 different places where color changes were made throughout our conversation history. This kind of historical reference can be very valuable in certain development situations. Let's try a new prompt. Was there any prompt that affected the size of the page width? By page width, we're talking about the HTML document layout. Let's send that to get a response. The answer came back indicating that we did change the format of the home page to include a sidebar, and that sidebar takes up 30% of the main page width. Again, this shows how Copilot is referencing our previous interactions. Let's move on to a different prompt. Was there any prompt that affected the size of the font on any of the pages? I'll click on the Send and Dispatch arrow. GitHub Copilot is working on my request. This one took quite some time to process, which is something you might want to be aware of when working with complex history queries. The response is showing me exactly where font sizes were changed throughout our conversation. If at any time during development you weren't quite sure of what exactly you did or what you asked, you could always go back into the prompt history and ask it to help you retrieve that information. You can also ask it what effect specific prompts had on your website or application. Now I want to request a comprehensive overview. My prompt is, show me a list of all the prompts used in this project so far. Once again, I'll click on the Send and Dispatch button and wait for the answer. Here's our answer. From the response, I have used 19 prompts so far, including the one that I just sent in. This comprehensive list shows the entire conversation history for this project. What we can do now is save all of these prompts to a text file for future reference. My prompt is, create a new text file and add this prompt list to that file. Also, place the file in the root of this project folder. Let's send that prompt, and what we should be getting back is not just a list, but an actionable response. Right at the top of where the prompts are being returned, there's an icon that looks like a file with a bent arrow pointing to the right. It's the very first icon that appears in the response section. If I click on that icon now, the command palette in top middle of the window will show me some options. I will click on New File project_prompts.txt option. This will create a text file with the prompts, which we can confirm by noting it in the File Explorer. All I have to do now is click on the Keep button, which is at the bottom right corner of the main editor window. Now, all of the prompts that I've passed in so far for this project are stored in that project_prompts.txt file. Now let me demonstrate something interesting about chat history. I'm going to right-click in the main chat window and choose the option for New Chat. With this new chat window opened up, I'm going to test whether the history is truly cleared. I'll go back into the prompts area and use the up and down arrow key on my keyboard to navigate to previous prompts. Let me go back to show me all the prompts where color was affected. I'll click the Send button, and GitHub Copilot is working on my request. Remember, I did clear the chat window and asked for a new chat window. However, I still get the same detailed answer about all the color changes that were made throughout the project. Even though I cleared the visible chat history, the system still maintains context about the project and can reference previous modifications. This raises an important question. How do you completely clear the entire chat history for a project? At the time of recording this demonstration, there is no official way of completely clearing chat history within the GitHub Copilot interface. However, if you really need to clear the chat history completely, you might need to look at browser-level solutions. You could examine the local storage or try clearing the browser's history, which may eventually clear the chat history itself. But other than these workarounds, there's no official way to completely erase the chat history. The system automatically manages and eventually clears chat history according to GitHub Copilot's data retention policies. This demonstration shows how powerful chat history can be for maintaining context throughout your development process, allowing you to reference previous decisions and track the evolution of your project over time. In this demonstration, we're going to explore how GitHub Copilot can help us learn a new programming language in its development environment. I've chosen Python for this demonstration. While I have some experience with Python code from previous projects, I've never built a complete application from scratch, so Python represents a genuine learning opportunity for me. What I have open on my screen is Visual Studio Code with its default blank interface that appears when you first launch the application. I'll start by accessing GitHub Copilot Chat, which appears as a panel on the right side of VS Code. If you don't see the chat window open, you can click on the Copilot icon located to the right of the search bar. When you hover over it, it displays Toggle Chat. I'm going to stretch this chat window out a bit so we can better observe the prompt I'm about to enter. This will be a very natural language prompt that demonstrates how conversational GitHub Copilot can be when helping us learn new technologies. Here's my prompt. I want to learn the Python language. Can you help me start a project and build a simple Python application that I can use to learn? I'll click on the right-facing arrow to send this prompt to Copilot's language model. Copilot responds by asking me to open an empty folder to continue. This immediately teaches us our first lesson about Python development. Like JavaScript applications, Python projects need a dedicated folder structure to operate properly. I'll click on the Continue button, which opens my system's file dialog asking me to select an empty workspace folder. I'll navigate to my Documents folder, then into my Projects folder where I store development work. Rather than selecting the Projects folder itself, I'll create a new folder specifically for this Python learning project. I'll right-click in an empty space within the Projects folder, select New from the pop-up menu, then choose Folder. I'll name this new folder PY for Python and press Enter. Now I can select this PY folder as my empty workspace folder by clicking the Select as Empty Workspace folder button. The dialog disappears, and Visual Studio Code now has a dedicated workspace to work with. VS Code is asking if I want to continue the workspace setup. Since I'm new to Python development, I'll click Continue Setup to let Copilot guide me through the process. Excellent. Copilot is now offering to install the Python extension for VS Code. This teaches us another important lesson. We need specific extensions in Visual Studio Code to work effectively with Python applications. I'll click Continue to let Copilot install the Python extension automatically. You can track the installation progress indicated by a clock icon next to the extensions icon in the left sidebar of VS Code. Once the extension installation completes, I'll click Continue again to proceed with the project setup. Copilot is now working to configure our learning environment. After a moment, It presents me with the option to continue iterating or send a new message to refine the prompt. I'll click Continue to see what Copilot has prepared for us. Perfect. Copilot has completed the setup and informs us that our beginner-friendly Python project is now set up. It has created several important files. A main.py file where we can start learning Python syntax and concepts. A README file with project information. A Copilot-instructions.md file for Copilot guidance, where we can add style guides or specific instructions. Copilot even provides instructions on how to run our Python code, either by opening the main.py file and pressing Ctrl+Shift+P, or using VS Code's Run menu. I'll click the blue Keep button to accept all these changes. Let me open the main.py file to examine what Copilot has created. I can observe it contains a typical Python structure with a def main function, a Python keyword. New. The def keyword is highlighted, indicating it's a Python keyword. All Python applications typically include this main method pattern. The function contains a simple print statement, and I notice there's also a line that reads if __name ___ equals __main ___ followed by main. Since I'm learning Python, let me ask Copilot about this pattern. I'll ask, why do we need line 8? Referring to the if __name ___ main ___ statement. Copilot explains that this line checks if the script is being run directly rather than imported as a module in another script. If the condition is true, it calls the main function. This is useful because it allows code reuse. If someone imports your file in another Python script, the code inside main won't run automatically. This is considered a common Python best practice for scripts and projects. Now let me ask another practical question. How do I execute the main.py file? I know Copilot mentioned this earlier, but I want clearer instructions. Copilot provides several options, including running it directly in the terminal by typing Python main.py and pressing Enter. Let me open a terminal window by going to the Terminal menu and selecting New Terminal. In the terminal window, I'll type Python main.py and press Enter. Perfect. It works, outputting Hello Python Learner. Welcome to your first Python project, which matches exactly what appears in line 5 of our main.py file. This demonstration has taught us several key lessons about Python development. Python projects require a dedicated folder structure. VS Code needs the Python extension for effective Python development. Python applications typically include a main.py file with a main function. The if __name ___ main ___ pattern is a Python best practice for script reusability. We can run Python applications both through VS Code's interface and directly from the terminal. Python function syntax differs significantly from C-style languages. Through this simple interaction with GitHub Copilot, we've established a complete Python learning environment and gained insights into Python development practices, all through natural language conversation with our AI assistant. In this demonstration, we're going to use GitHub Copilot to help us convert a JavaScript application to a TypeScript application, showcasing how AI can simplify the process of converting code between related programming languages. What I have open on my screen is Visual Studio Code pointing to a simple JavaScript web-based application in a folder called Webform App. VS Code is organized into 4 distinct panels. On the left, we have the Explorer window showing all files in our project folder. In the middle, the main editor window. To the right of the editor, the GitHub Copilot chat panel. And below the main editor, the terminal window. If GitHub Copilot chat isn't available, you can open it by clicking the icon to the right of the search bar in VS Code. Currently, I have the index.html file open in the editor. Before we begin the conversion process, I want to provide Copilot with complete context about our application. I'll drag the validation.js file from the Explorer window into the context area of GitHub Copilot chat. Now I'll also drag the styles.css file into the context area. This ensures that GitHub Copilot has access to all 3 key files: index.html, validation.js, and styles.css, when making decisions about the conversion. For this conversion process, I'm going to use a straightforward, natural language prompt. I'll place my cursor in the chat input area and type my request. Convert this JavaScript-based application to a TypeScript-based application. I'll send this prompt to the language model by clicking the right-facing arrow at the bottom right corner of the chat window. GitHub Copilot is responding with a comprehensive conversion plan that includes several distinct steps. It's going to update our index.html file, install TypeScript, and create tsconfig.json file, and add proper types to our validation.ts file. Scrolling down, I can observe that after step 4, Copilot says, let's start renaming the file and installing TypeScript. The first action it wants to perform is renaming the validation.js file to validation.ts in the JS folder. I'll click the blue Continue button to proceed. Checking the Explorer window on the left side, I can confirm that under the JS folder, we now have validation.ts instead of validation.js. The file has been successfully renamed. The next command Copilot wants to run is npm init to initialize our node.js project. I'll click the blue Continue button again, and this command will execute in the terminal window. Once that command completes, you'll see that a package.json file has been created in the Explorer window. This is the result of running npm init. Back in the chat window, the next command we need to run is to install TypeScript itself. I'll click Continue again to let Copilot install TypeScript for us. In the terminal window, you can track the installation command running, and we'll need to wait for it to complete. The installation has finished, and we now have a node_modules folder visible in our Explorer window. If I open the package.json file, I should see TypeScript listed as a development dependency. I'll close the package.json file now. Back in the GitHub Copilot chat window, there's one more command to run, the TypeScript initialization command using npx. I'll click Continue one more time to execute this command. After this command runs, I can confirm that the tsconfig.json file now appears in our Explorer window, along with several other configuration changes that TypeScript requires. In the main editor window, Copilot is suggesting we change the script reference in our HTML file from validation.js to script.js, noting that TypeScript will compile back to JavaScript. I'll click the Keep button to accept this change. Back in the chat window, Copilot is explaining that we need to compile our TypeScript code by running npxtsc in the terminal window. This will generate a new validation.js file in the JS directory from our TypeScript source. Copilot also recommends updating tsconfig.json file to specify the appropriate input and output directories for our project structure. Excellent. Our JavaScript-based application has now been successfully converted to a TypeScript-based application. The conversion process completed without any apparent errors in the terminal or editor. However, if I examine the validation.ts file in the editor, you'll notice there are several syntax highlighting markers and potentially some logic issues that need attention. While the overall conversion process went smoothly, not every detail was handled perfectly. This is where you can use GitHub Copilot iteratively to help you work through each of these issues and refine the converted code. Once you've addressed any remaining issues, you can run the npxtsc command in the terminal window. This will compile your TypeScript code and generate a new JavaScript file that your index.html can reference, completing the conversion process. This demonstration shows how GitHub Copilot can handle complex, multi-step code translations while maintaining project structure and dependencies. While the AI handles the bulk of the conversion, developer oversight remains important for reviewing and refining the results to ensure everything works correctly in your specific context. In this demonstration, we're going to explore GitHub Copilot's ability to handle context switching by seamlessly adapting to different technologies within the same development environment. What I have open in my workspace is Visual Studio Code on the left side, pointing to a complex TypeScript application. On the right side of my screen, there's a browser window that automatically refreshes every time I make changes to the code on the left side. This represents a typical TypeScript development setup with live reloading capabilities. Context switching occurs at various levels in software development, in operating systems, programming languages, asynchronous programming, parallel processing, and multi-threading. However, in the context of GitHub Copilot, we're referring to its ability to adapt to the current and evolving coding environment. Copilot analyzes the code being written, the cursor position, any selected code, and the chat history to provide relevant and intelligent responses. Let me start by asking GitHub Copilot to analyze our current project. My prompt will be, analyze this project in the ts_js_ context folder. I'll send this to the language model and wait for the response. Here's the response from Copilot. It's quite comprehensive with several bullet points, but I want you to pay particular attention to bullet point number 5. Even though this is primarily a TypeScript project, GitHub Copilot was intelligent enough to identify that the project includes a months.js file, indicating a mix of TypeScript and JavaScript files. This observation is extremely important because it demonstrates Copilot's contextual awareness. You can observe this mixed language setup in action by checking the browser on the right side. When I click on the drop-down arrow in the browser, the options display as 1, 2, and 3 basic numeric options. If we review the main.ts file in our project, you'll find that there is a for loop on line 18. This for loop uses a simple counter that goes from 1 to 3. And these values are used as the options displayed in the drop-down list box. Now I'm going to demonstrate context switching by clearing the chat window and requesting a new chat session. In the main editor window, I have 3 files open, main.ts, months.js, and index.html. Currently, main.ts has focus. I'm going to switch focus to the months.js file. Observe that I'm now switching from a TypeScript file to a JavaScript file. In the chat window, I'll enter a simple prompt, export the months object. I'll send this prompt by clicking the right-facing arrow at the bottom right corner of the chat window. GitHub Copilot has understood my request and is suggesting adding the export keyword on line number 1. In the editor window, I can access options to either keep or undo this change. I'll click Keep to accept the modification. Now on line number 1 in my months.js file, we have the export keyword in front of the const keyword, making the entire months object available for export. With that change in place, I'll now switch context back to the TypeScript file, main.ts, and enter another prompt in the chat window. Here's my new prompt. Use the months object to replace the numbers being shown in the browser with the strings in that months object. Notice that I haven't specified any file names. I'm simply referencing the months object. I'll send this prompt to the language model and wait for the response. The response demonstrates Copilot's sophisticated context awareness. It's starting by importing the months from months.js. Notice that Copilot understands the months object is coming from a JavaScript file. Beyond that, it has modified the for loop to display the month strings from the object instead of numeric values. I'll keep all of these changes by clicking the Keep button. Checking the browser on the right side, we can now find January, February, and March instead of the previous numeric values. While line number 3 still indicates a syntax warning, which is an advanced TypeScript configuration issue, the important point is that we successfully combined JavaScript and TypeScript to solve a programming problem. Most significantly, GitHub Copilot was able to seamlessly switch context between different programming languages, understanding when I was working with JavaScript versus TypeScript, recognizing the relationship between files in different languages, and providing appropriate suggestions for each context. This example illustrates how Copilot minimizes the cognitive overhead of context switching by maintaining awareness of your entire development environment, allowing you to focus on solving problems rather than managing the complexities of multi-language projects. In this demonstration, we're going to use GitHub Copilot to help us generate comprehensive documentation for one of our existing projects, showcasing how AI can streamline the documentation process. What I have open in my workspace is Visual Studio Code split into 3 panels. On the left, the Explorer window showing all files and folders in our project. In the middle, the main editor window. And to the right, the GitHub Copilot chat panel with its input box at the bottom. If the GitHub Copilot chat window isn't available, you can open it by clicking the icon located to the right of the search bar in VS Code, which will open the chat panel. This project is a work-in-progress application that has already been started, so it's not a simple starter project. Checking the Explorer window on the left side, we can find all the files and folders that make up this application. However, you'll find that the README file is missing. This is exactly where GitHub Copilot can provide powerful assistance. I'm going to enter a prompt in the GitHub Copilot input box. Here's my request. Analyze this project folder and generate an appropriate README file. In the input box, there's a right-facing arrow. I'll click on it to send my prompt to GPT 4.1, which is the model I have selected, and wait for the response. As shown here, GitHub Copilot is collecting information about my workspace and analyzing the project structure to understand what kind of application this is. Here's the response from Copilot. It's telling me here is a suitable README file for your project and has generated comprehensive content that can be included in that file. At the top of the response, I can access several icons. The leftmost icon looks like a file with a bent arrow facing to the right. When I hover over it, it displays Apply in Editor. Currently, I have my index.html file open in the editor, so I don't want this README content to be inserted into that HTML file. I'll click on the icon, and VS Code gives me two options. I can either apply the content to the index.html file, or I can choose the New Untitled Editor option. I'll select the New Untitled Editor option, which opens a new file dialog asking me to save this new file. I don't want to use the default name that appears, so I'll change the file name to README. In the file dialog, I'll change the name to readme.txt and click the Save button. Now back in VS Code, I have a new readme.txt file at the bottom of the Explorer window, positioned at the root of my project folder. When I click on it, I can access all the content that GitHub Copilot suggested is now part of this README file. Without writing a single line myself, I've created a readme.txt file containing 95 lines of comprehensive documentation. I'll close the readme.txt file and navigate back to the Explorer window on the left side. I'll scroll down to find the Components folder, expand it, and locate the Login component. Clicking on the right-facing arrow next to Login reveals 3 files inside. I'll select the main.jsx file. Now I'll go back to the GitHub Copilot chat window and ask about this specific file. Here's my new prompt. Add a comment at the top of this main.jsx file that describes what this file does. I'll click the right-facing arrow to send this prompt to the model and wait for the response. Here's the response from Copilot. I can click on the leftmost icon at the top of the response to apply these comments to the file. After clicking the icon, I need to click the Keep button at the bottom right corner of the editor window to save these changes. The comments have now been added to the top of the main.jsx file. Let me demonstrate one more documentation feature. I'll go back to GitHub Copilot and ask it to analyze the file structure and add comments to the individual processes. Here's my prompt. Analyze this file, search for the processes, and add a one-line comment at the top of each process. I'll click the right-facing arrow to send this prompt to GPT 4.1. GPT 4.1 is responding, and I can confirm it has identified the various processes in the file and generated appropriate comments. I'll click on the same file icon to apply these changes to the main.jsx file. The system has added a comment at the top of each process in the file. I'll click the Keep button in the editor window to save all these documentation improvements. Now my main.jsx file has comprehensive inline documentation that explains what the file does and describes each individual process within it. This demonstration shows how GitHub Copilot can be an excellent tool for generating both project-level documentation, like README files, and inline code documentation. As you develop your applications, you can use Copilot to maintain comprehensive documentation that makes your code more maintainable and accessible to other developers. The AI's ability to analyze project structure, understand code functionality, and generate appropriate documentation in consistent formats makes it an invaluable partner in maintaining high-quality, well-documented code bases. In this demonstration, we're going to use GitHub Copilot to add sample data to an existing application, showcasing how AI can streamline the process of creating realistic test data for development purposes. What I have open in my workspace is Visual Studio Code on the left side, and to the right is a Firefox browser window. VS Code is split into 4 distinct areas. On the left is the Explorer window, in the middle is the main editor window, below that is the terminal window, and to the right of all those is the GitHub Copilot chat window. This is an existing React application that's considerably larger than some of the other projects we've been examining, but we won't dive deep into the code structure. What I want to demonstrate is how this React application needs sample data and how GitHub Copilot can help us generate that data efficiently. First, I'm going to add a local server to this application. I'll go to the terminal window and add the necessary command. While I could use GitHub Copilot for this task, it's straightforward enough that I'll handle it manually. Here's my command, npm install JSON server. I'll press enter and wait for the JSON server to be installed in this application. Now that the JSON server has been installed, I'll issue the clear command in the terminal window to give us a fresh workspace. The JSON server will need a dataset to serve at the browser level, and this is exactly where GitHub Copilot becomes invaluable. First, I'm going to use the Explorer window in VS Code to add a new folder to this project. I'll click in any white space within the Explorer window, then hover over the folder icon at the very top of the Explorer window. When I hover over it, it displays New Folder. I'll click on that icon. VS Code allows me to create a new folder, which I'll name Data. Once that's done, I'll click away to accept this addition to the project folder. Now that I have the data folder, I'm going to ask GitHub Copilot to create a new file for me in that folder. In the Copilot chat input box, I'll enter my prompt. Here's my request. Create a new file called db.json inside of the data folder of this project. There's a right-facing arrow at the bottom right corner of the input box. I'll click on it to send my prompt to the model. GitHub Copilot has responded with a Create File button. I'll click on that button, which opens the Windows File dialog box. Notice that the file name is already set to db.json, exactly as I requested. In the Windows dialog, I'll click Save File rather than Cancel. Back in my VS Code editor, I can see the db.json file has been created in the data folder. Now I'm going to ask GitHub Copilot to add sample data to this file. In the chat input box, I'll enter another prompt. Here's my request. Create an employees array, and inside of that array, notice that I haven't given GitHub Copilot any specific instructions beyond creating 3 employee objects inside an employees array for the db.json file. I'll click the right-facing arrow to send this prompt to the model and wait for the response. Just like that, here's my response. Remember, I didn't provide detailed specifications. I simply asked for 3 employee objects. At the top of the response, there are several icons. The leftmost icon looks like a file with a bent arrow facing right. When I hover over it, it displays apply to data/db.json. I'll click on that icon. All the content that GitHub Copilot generated is now inserted into the db.json file. I need to move my mouse to the editor window and click the Keep button at the bottom to save these changes. As shown here, this employee's data includes names, positions, departments, and even ID numbers. I have 3 complete employee objects, and all I had to do was provide a simple prompt to GitHub Copilot. If I want to enhance this data further, I can go back to the GitHub Copilot chat window and make additional requests. For example, let me add email addresses to each employee. My prompt is, add an email field to each employee object. I'll send this prompt to the language model and wait for the response. Here's the response. I'll click on the file icon again. When I hover over it, it shows apply to data/db.json, and then click Keep in the editor window. Perfect. Now I have an email field added to each employee object. There's one more thing I can do with this employee data. I can ask GitHub Copilot to configure the JSON server we installed earlier so I can serve this db.json file through the browser. Here's my prompt. I want the JSON server to watch this db.json file. I'll click the right-facing arrow and wait for the response. The response provides the complete command to start our JSON server, configure it to watch the db.json file, and even specifies the port number. Remember those 3 icons I mentioned earlier? The leftmost one adds content to open files, but if I move to the right, I observe 3 ellipses. If I click on those ellipses, I get additional options, including Insert into Terminal. I'll select Insert into Terminal, which places the command directly in my terminal window. I'll move to the terminal and press Enter to execute the command. Once the command runs, you can see that the JSON server has responded, confirming it's hosting my db.json file at localhost port 3000, exactly as specified in the chat response. Now I can open a second browser tab and navigate to that address. When I go to localhost 3000, I can access my 3 employee objects exactly as GitHub Copilot created them, now being served as a live API endpoint. This demonstration shows how GitHub Copilot can rapidly generate realistic sample data, customize it to your specifications, and even help configure the infrastructure needed to serve that data during development. This streamlined approach to test data generation can significantly accelerate your development and testing workflows. In this demonstration, we're going to use GitHub Copilot to help us modernize a simple JavaScript-based application, showcasing how AI can identify outdated code patterns and upgrade them to modern standards. What I have open in my workspace is VS Code split into the usual 3 panels. On the left is the Explorer window pointing to our project folder. In the middle is the main editor window currently focused on the scripts.js file. And to the right is the GitHub Copilot chat window. I also have a browser open because we'll be making changes to this file, and the browser will refresh automatically to show us the results of our modifications. GitHub Copilot can help developers identify, refactor, and upgrade legacy code to modern standards. JavaScript is a language overseen by the ECMAScript standards body, which regularly makes improvements and additions to the JavaScript core language specification. Let me close the Explorer window since we don't need it for this demonstration and focus on the scripts.js file. Examining the displayData function, you can find we're getting one of the div components from the HTML file using getElementById. We're then constructing div tags based on the employees array, creating 5 new div tags, and once those div tags are organized, we add them to the container on our HTML form. When this process completes, the HTML form expands to display the employee data. Checking the browser window, you can find we're currently displaying 5 employees from our employees array. My first task is to ask GitHub Copilot to analyze the displayData function and provide insights about it. If the Copilot chat window isn't open, you can click the icon to the right of the search bar in VS Code to open it. I'll place my cursor in the input box and enter my first prompt. Tell me about this function displayData. Since there's only one function in the file, this should be unambiguous. I'll click the right-facing arrow at the bottom right corner of the input box to send this prompt to GPT 4.1. Here's the response from Copilot. If I scroll down a bit, I notice it says, Issues to fix. Copilot has identified several issues that don't conform to the most modern ECMAScript standards. It's suggesting we need to address these issues, and at the bottom of the response, it asks, would you like a corrected version? In the input box, I'll reply with a simple yes and press enter. GitHub Copilot has returned with several suggestions for modernizing the code. I'll accept these suggestions by clicking the leftmost icon at the top of the response box. When I hover over it, it shows Apply to Scripts/Scripts.js. I'll click on that icon. All the content from the chat window is now being transferred to the Scripts.js file. I need to click the Keep button at the bottom right corner of the editor window to accept these changes. Our code is now much cleaner and follows modern standards. But with GitHub Copilot, we can go even further with modernization. I'm going to ask Copilot about a specific improvement. In the input box, I'll enter, "Is there a better way to write the for loop on line 13?" I'll click the right-facing arrow to send this prompt to the model. Here's the answer. Yes, you can use the for each method. If I scroll down, I can see that Copilot has actually implemented the modern for each approach for me in the chat window. To accept this modernization, I'll click the leftmost icon at the top of the response box. The changes are now applied to my display data function. I'll click the Keep button at the bottom right corner of the editor window, and you can find that line 13 now uses a modern for each implementation instead of the traditional for loop. But there's even more we can do. I can highlight the entire function, right-click in the highlighted area, select Copilot from the pop-up menu, and then choose Editor Inline Chat from the submenu. This opens an input box directly within the editor window with a prompt asking me to communicate with Copilot. I'll simply type "Improve this function" and click the right-facing arrow in the inline input box. This time, all the modernization changes are being made directly within the editor window itself. I'll click the Accept button at the bottom of the input box to apply these improvements. Notice that we have a slightly different implementation of the display data function that's more modern and efficient. At the same time, checking the browser window, we're still getting the same results. Our 5 employees are still displayed correctly. Let me add one final modernization prompt. I'll enter, "Bring this scripts.js file up to ECMA script latest standards." I'll click the right-facing arrow to send this comprehensive modernization request. Once again, Copilot has generated updated code that follows the latest ECMA script standards. While the changes aren't dramatically different from what we had before, I'll accept them by clicking the leftmost icon at the top of the response window. The changes have been applied. I'll click the Keep button in the editor window to save these final modernizations. Now we have a thoroughly modern display data function and an updated scripts.js file that follows current ECMA script standards. The browser continues to display our employee data correctly, but the underlying code now uses modern JavaScript patterns, improved syntax, and current best practices. This demonstration shows how GitHub Copilot can systematically identify legacy code patterns and guide you through modernizing them step by step, ensuring your applications benefit from the latest language features while maintaining their functionality. In this demonstration, we're going to use GitHub Copilot to help us identify and fix a bug in our code, showcasing how AI can enhance debugging efficiency by analyzing errors that might not be immediately obvious. What I have in my workspace is VS Code pointing to a very simple web-based application. On the right side of VS Code, there's a browser window that automatically refreshes whenever we make changes to either the HTML or JavaScript files. Examining the JavaScript file, you can find that on line 1, we're getting a reference to a div tag from the HTML document. On line 2, we have an array containing 3 strings which represent names. Then on line 10, we're using that HTML div reference and iterating over the names from line 2, passing each string to the proper name function on line 4. The proper name function takes each string and returns it with the first letter capitalized. This way, we're converting all the names in our array to have proper capitalization with uppercase first letters. Now I'm going to manually introduce an error into this code to demonstrate Copilot's debugging capabilities. On line 5, I've added a setTimeout function. Once this setTimeout function is introduced, the entire program stops working correctly. However, if you check the browser's console window, you don't find any error messages appearing. Back in the editor window, there are no red squiggly lines or other warning indicators of errors either. We have no obvious visual cues that there's a problem, but we know something is wrong because nothing is displaying in the browser window. Let's see if GitHub Copilot can help us identify and resolve this issue. I'm going to use the inline chat feature of GitHub Copilot. First, I'll highlight all the lines in the scripts.js file by selecting the entire code block. With all lines highlighted, I'll right-click in the highlighted area. From the pop-up menu that appears, I'll choose Copilot. And then from the secondary pop-up menu, I'll select Editor Inline Chat, which is the first option at the top. This opens an inline chat window with an input box directly within our code editor. I'll enter my debugging prompt in this input box. Here's my prompt. I do not see any output in the browser window. I want to keep the setTimeout function. That second sentence is crucial. If I didn't specify that I want to keep the setTimeout function, GitHub Copilot would likely suggest simply removing it. But that's not what I want in this scenario. With my prompt entered, there's a right-facing arrow to the right of the input box. When I hover over it, it displays Send and Dispatch. I'll click on it to send my prompt to the language model GPT 4.1. The response has come back, and remarkably, checking the browser window, our names have reappeared and the first letters of each name are properly capitalized again. In the editor window, I have two options, Accept or Close. I'm going to click the Accept button below the input box to accept the code changes that Copilot suggested. Now I'll click away into any white space in the editor so we can see the updated code more clearly. Notice that GitHub Copilot has solved the problem using something called a promise object. This is a sophisticated JavaScript concept that handles asynchronous operations properly. The promise-based solution is quite elegant. It addresses the timing issue that the setTimeout function created without removing the setTimeout functionality I wanted to preserve. This represents a complex debugging scenario that neither VS Code's error detection nor the browser's console caught, but GitHub Copilot was able to identify and resolve. Checking the browser window, we still have our setTimeout function working as intended, and we're getting exactly the same results as before. Our names are displayed with proper capitalization. This demonstration illustrates how GitHub Copilot can serve as a powerful debugging partner, identifying subtle timing and asynchronous programming issues that might not trigger obvious error messages. The AI's ability to understand the intent behind your code and provide sophisticated solutions like promise-based patterns can significantly enhance your debugging efficiency, especially when dealing with complex JavaScript timing issues. The key takeaway is that Copilot doesn't just fix syntax errors. It can analyze logical problems and suggest architectural improvements that resolve deeper issues in your code while preserving the functionality you want to maintain. In this demonstration, we're going to start working with testing using GitHub Copilot. What I have opened up on my screen is VS Code, and it is pointing to a very simple TypeScript application. In fact, we have just one file, index.ts, which we'll be using to start our testing journey. Now, the first thing that I'm going to do is ask GitHub Copilot to add testing to this project. For that, I'm going to go into the GitHub Copilot chat area, which is on the right side of my VS Code. If that chat window is not opened, click on the GitHub Copilot chat icon, which is on the right side of the search bar in VS Code. That search bar is at the top of VS Code. So, now in the input box of my chat window, I'm going to pass a simple prompt. My prompt is add testing to this project, and I also changed my model from Gemini to GPT 4.1. Now, I'll click on the right-facing arrow at the bottom right-hand corner of that input box. My prompt will go over to the large language model, and now I wait for the response. Here's the response. It is rather long, so I will go to the main topic, which is that we need to install Jest and a couple of other libraries. Now, within that chat window, at the very bottom of the response, I have two options, either continue or cancel. I'll click on the blue continue button in the chat window, and what that is going to do is install all of the libraries that are needed for testing. Notice that the terminal window opened up and I did not have to do any manual work. Now, I'm being given a second command in the chat window, and the command is to initialize Jest configuration for TypeScript using tsJest. Once again, I can either cancel or continue. I'll click on the blue continue button to the left of the cancel button, and the installation continues. Now quite a few things have happened, and it seems that I have to click on the keep button within the editor window so that the index.test.ts file is saved before we can continue on. So I'll click on the keep button there. It's in the bottom right-hand corner of the editor window. I have options of keeping, undoing, or choosing one of the other options. So, I will click on the Keep button and make sure that the index.test.ts file is kept. We are now in index.ts looking at a code change where export has been added to our employee object. We need to export that employee object in order to test it. Now, I'll click on the Keep button again, and my employee object will be exported. Now, notice on the right side in the chat window, something else is going on there. We need to run the command npx-jest within the terminal window. Once again, I have to either continue or cancel. I'll click on the Continue button in order to let that installation take place. After all of that, it created the index.test.ts file for me, and it actually ran the test as well. There's also a summary. It says testing has been added to your project using jest and tsjest. A sample test file, index.test.ts, was created and all the tests are passing. You can now add more tests as needed. Now that we only have one employee object, which can be considered a unit test, I'm going to add another object to the index.ts file and test it using an integration test. If you look at my index.ts file, which is the main file for this project, we now have two objects. One starting on line 2, which is an enum. It's simply 5 key-value pairs. Then on line number 10, we have our original object, the employee object. Now, I will reconfigure this employee object to be able to use that enum object above. So, I'll add payday, and that will point to weekdays. Now notice that GitHub Copilot is helping me all the way through. A right-facing arrow appeared right after I added the 4th key-value pair within the employee object. If I scroll down a bit, all I really need to do is click the helper arrow. Now it turns into a checkbox as I hover over it, and payday will be using the Friday key, so that should return Friday as well. Great. So now that we have these two different objects, I'm going to go back into GitHub Copilot, and I'll prompt again to use an integration test. So here's my prompt. Create an integration test so that the enum is consumed properly by the employee object. Once again, I'll click on the right-facing arrow at the bottom right-hand corner of the input box and wait for the response. So here's my response. I will scroll up just a bit so that we can see if there were any changes made. And in fact, it did create a second file. It created a file called employee.integration.test.ts. Now, all we need to do is run the command npx-jest in the terminal. I'll make sure I keep all the changes by clicking on the Keep button. Now, I can either click on Continue to run npx-jest, or I can go into the terminal window. I'll clear the terminal window first. I'm seeing that the employee integration test.ts file is still busy, so I'll click on that now to make sure that I did save all of those changes. I did. I'm not sure why it shows as though it's busy. That might be a bug with VS Code. Anyway, I'll go into the terminal window now and run npx-jest. We wait for the response, and now we have 2 test suites. And we have all 5 tests passing. So, in this demonstration, we showed you that you can do integration tests as well as unit tests using GitHub Copilot's powerful testing capabilities. In this demonstration, we're going to use GitHub Copilot to help us find edge cases within our code and have GitHub Copilot build test cases to test those edge cases. What I have on the screen is VS Code. It's opened up to a very simple application. It's a web-based application. And on this project, we have an index.html file with a form in it. The form is very simple. We have a username and an email field. Currently, I have a validate.js file opened, and it is the initial context for GitHub Copilot. Now this project does not have testing on it at all. No test libraries have been installed. So what I will do is go into GitHub Copilot. If GitHub Copilot is not opened, click on the icon to the right side of the search bar in VS Code. That will open up the chat window on the right side of VS Code. So in the input box of GitHub Copilot chat, I will pass my command to the large language model. And my prompt is very simple. Add testing to this project. Once again, I'll click on the Send button, which is a right-facing arrow at the bottom right-hand corner of that input box. I'll click it now and wait for the response. Now I did get a response. Now whenever I have multiple things going on, I always go to the editor window first. Notice that I have a few options there. GitHub Copilot is offering to keep the code that I have in validate.test.js, or I can undo the changes. Now validate.test.js happens to be a new file, so I will click the Keep button, which is the leftmost option. I'll click on that now within the editor window. And that file has been saved. However, I do need to make a change to the package.json file, so it's asking me to accept that change as well. So once again, I'll click on the Keep button to keep that change. Now over on the right side, we have to install a few things. So GitHub Copilot is asking me to install Jest and something called JSDOM, two libraries. I'll click on the Continue button to have that installed in my system, and we'll wait until it's finished. So it looks like the installation was complete. I also see that two files have changed, but I did not get an opportunity to save the changes. So what I'll do is I'll switch back over to validate.test.js. Notice that there's a circling circle icon indicating that something is going on with this file. So I'll click on it now and I'll attempt to see what the problem is. I don't see any glaring problems here, so I think that this is a VS Code bug. Nevertheless, let's go ahead to the right side of VS Code where our npm test is. Below that, we have two options. I can click on Continue or Cancel. Of course, I'll click on Continue to see if the test will indeed pass. And it looks like the tests have passed. And now I get a message. Testing is now set up for your project using Jest and JSDOM. We created a validate.test.js file to your project, and of course we can add more tests. Before I continue, I will close a few of the windows. I'll close the validate.test.js file as well as the package.json file, and I'll move back into the input box for GitHub Copilot chat. Now I've clicked on the validate.js file, and my prompt is very simple. I want to test for edge cases in the validate.js file. Start with the username field. Now, I haven't given it any other instructions at all, just this simple sentence. So once again, I'll click on that right-facing arrow at the bottom right-hand corner of the input box and wait for the response. And here is the response. If I go to validate.test.js, which is the new file that was added for me by GitHub Copilot, notice that the shaded area contains all of the test cases that it wrote for that one field, and it's quite a lot. So I did not have to write a single test case here. So once again, in that editor window, I get the option to keep or undo. Of course, I'll click on Keep so that the test cases are kept. Over on the right side in GitHub Copilot, notice that I can continue. If I click on the Continue button in this case, the npm test command will run, and so all of those tests in validate.test.js will run. Now, I could also go over into the terminal window and run the tests from there. Notice that the first test that we actually ran was one test suite that represented 4 individual test cases. I'll run the command npm test one more time within the terminal window. I'll hit the Enter key and let's see what happens now. So remember, we had 4 tests before. Now we have 8 tests being passed, and I did not have to write a single line of code. This demonstrates how GitHub Copilot can automatically identify and create comprehensive test cases for edge cases that you might not have considered, significantly improving your test coverage with minimal effort. In this demonstration, we're going to add a boilerplate testing environment for our application. What I have opened up on the screen is VS Code. It is split into the usual 3 windows. On the left is the Explorer window. It shows us the files and folders that belong to my project. It's a web-based project, and it's very simple. In the middle, we have our editor window, and then to the right of that is my GitHub Copilot chat window. If your chat window is not opened, please click on the icon to the right side of the search bar in VS Code. It's at the top of VS Code. Now, in order to start up a boilerplate testing environment for this web-based project, I'm going to attempt to do it with just 2 prompts. And my prompt is very simple. Set up unit and integration testing with Jest. That's it. That's our first prompt. Now, I'm going to click on the right-facing arrow. It's at the bottom of that input box. And notice that I have GPT 4.1 selected as my large language model. So I'll click on that arrow now and wait for the response from GPT 4.1. So here's our first response. GitHub Copilot is asking me to install Jest and Babel dependencies. Now the entire installation command is already set up. I have two options, continue or cancel. I'll click on the Continue button, and GitHub Copilot will open up the terminal window for me and will add that installation command into the terminal window and run the installation for me. GitHub Copilot will add quite a few files and folders to this project. So in the Explorer window, that area will expand quite a bit. Okay, so it looks like our installation is complete, and notice that GitHub Copilot is continuing to add files to the project. Notice that the interface has gotten quite busy. There's a lot going on. I'll wait for the installation to settle down a bit, and then we can continue on. Whenever something like this happens where there's a lot of activity, the first thing that I will do is focus on the editor window. Within the editor window, notice that there are quite a few files that have been added and some changes to the existing files. So, in that editor window, GitHub Copilot has given you the option to either keep or undo the changes that were just made. At this point in time, GitHub Copilot has opened up a tab to a file called .babelrc. So, if I click on that Keep button, which is at the bottom right-hand corner of my editor window, .babelrc file will be saved. So that's now saved. Copilot has added 4 more files, and I will review and keep all of them. The package.json file did change. I'll click on that Keep button to keep those changes or save those changes. Now that all of the changes have been saved, notice that we do still have a bit of an animation going on for each of those saved files. Now, that could be a bug in VS Code. Remember, Copilot is a work in progress. Now, over to the right side, we see that there's yet another command that needs to get run, and this is the npm test command. Now remember, the package.json file did change, so if I run my test now, the Jest library will take over and run the tests that it added to my application. So, I'll click on Continue in the chat window and wait for those tests to run. Now notice that we did have a bit of a problem in the terminal window. It has something to do with the Jest environment JSDOM library. So GitHub Copilot noticed that this library has an issue, and over in the chat window, it is asking me to install that library. Notice how everything is working in coordination. Now, if I click on that Continue button in the chat window, hopefully that environment or that library will be installed, and we can test again. While that installation is continuing, if you notice a little bit further down in the chat window, we have quite a few files that were added to this project. So, GitHub Copilot is letting us know that 6 files have changed. As a matter of fact, some of these were added. I believe 5 of these files were added and the other one changed, which is the package.json file. Okay, so our installation is now complete. So, GitHub Copilot is offering to run that test command again. If I click on Continue, the test will run, and hopefully, this time it will be successful. So yes, the test did run, and we see that 2 tests pass, and it seems that our testing so far is working. As a matter of fact, if you go back into the chat window, GitHub Copilot is reporting that you can now add more tests to the test directory, and then you can run npm test from that point on. So, our boilerplate testing environment is starting to look really good. Now further down, where we have our files changed, notice that these files will remain in your interface until you remove them. In order to get rid of these files, if you hover over them and move your mouse cursor over to the right, there is an X. If you hover over that X, it will say Remove File. So I'm going to remove all of these files because we no longer need them in this area. So I have removed all of those files, and now we're back to a clean interface. Now remember, I did say that we were going to use 2 prompts in order to build our testing environment. So far, we have unit testing and integration testing already done in our system. What I'm going to do now is go into the chat window and add my second prompt. Set up end-to-end testing with Cypress. Once again, I'll click on that right-facing arrow at the bottom right-hand corner of the input box, and my prompt will go over to GPT 4.1, and I'll wait for that response. Here's my first task. It says npm install save dev Cypress. All I have to do is click on the Continue button, and Cypress will be installed in my project folder. Now, Cypress is a heavy application. It uses up a lot of libraries, so this may take a while to install. So, with Cypress installed, notice that quite a few more additions have been made to my project folder. Once again, I will start with the editor window, and I will click on the Keep button there to keep the new file that Cypress installed. So it's the cypress.config.json file. I'll click on Keep to save that file. And we have another file, registration.sci.js. I'll click on the Keep button there to save that, and a change has been made to our package.json file. Once again, I'll click on the Keep button to make sure that I save that. So now that Cypress has been installed, if I move my mouse over into the chat window and scroll up a bit, you will see that we were given instructions on how to open up Cypress and how to run Cypress. So with just 2 commands, I have now set up my development environment to perform unit tests, integration tests, as well as end-to-end testing. This demonstrates the power of GitHub Copilot in quickly establishing a comprehensive testing boilerplate for your projects. In this demonstration, we're going to work with test assertions in a project, and we will utilize GitHub Copilot to help us develop these assertions. What I have opened up on my screen is VS Code. It is pointing to a very simple web-based application with a JavaScript file, a CSS file, and an HTML file. Now, this project already has testing installed within it. In the package.json file, you will see that Jest is installed as well as a couple of other libraries that are needed for this project. In the project, we also have a scripts.test.js file. This file already has some code in it. Here, we are setting up a mock HTML structure to simulate the real HTML form on the index.html file. We do this because we can run unit tests in environments like node.js where we don't have a real browser. Other than that, we have a describe function, which of course creates a test suite. In this case, the test suite is named form validation. The describe function or test suite is how we can group related tests in one place. So here is where we're going to start our assertions and write test cases for each assertion. Then below that, we have a before each function. Every time we run a new test, we are going to simply clear all of the fields from their values and start with a fresh form. Now, before we continue on, I should mention that Jest has a very rich assertion library. With Jest, we use the word expect when we want to ensure that our test is working properly. Now my chat window is open in VS Code. It is to the right side of the editor window. If yours is not open, click on the icon to the right side of the search bar at the top of VS Code. Now I'll go down into the input box within the chat window and notice that my scripts.test.js file is the current context. I'm going to start my first prompt. Here's my first prompt. I want to add a new test case to check the username field. Can you suggest a few test cases? Very simple prompt. I am going to now click on the right-facing arrow at the bottom right-hand corner of that input box. Note that we have GPT 4.1 as the default large language model. I'll click on that arrow now, and let's wait for the response. The response has come back, and it is suggesting that I install another library, orta.vscode-jest. I can either accept or dismiss, so I'll click on the Accept button and the installation will take place. Of course, I have to accept from the pop-up window to trust the publisher and install. I'll click on that now so that VS Code has the permissions to install this extra library. Now the installation is complete. I will close the window at the bottom right-hand corner so that VS Code is updated. And now we have some information, some new detail inside of the scripts.test.js file. I will click on the Keep button to keep those changes. I'll scroll down a bit, and here we see a few test cases being written. So, in the first case, we're going to be testing our username for any values in there. So, in other words, if this is empty, we should have a certain behavior. In our case, the error message, which happens to be on the HTML form, should contain some text like username is required. And there should be some other changes in terms of the CSS. So that's all within 3 expect functions. Without writing a single line of code, GitHub Copilot has already written the first test for me, and it is testing quite a few different parts of that username input field. If I scroll down just a bit, there's another test. Our test here in this case is that the username should not show an error if the username is provided, and that is indeed correct. So, if a value was placed into that input box, then once again, the error message should not show anything. So the error assertion here is, we expect that the error message does not to contain the words username is required. We also expect a certain change in the CSS as well. If we scroll down a little bit further, there is a test on if we trim the whitespace in username. So, for example, in this case here, they've added in a test where there's whitespace on both sides of that username. And here we're checking to make sure that trimming takes place. If we scroll down a little bit further, there's yet another test where we are showing an error if both the username and email fields are empty. Now I did not ask about the email field, but they did suggest that. So, with just one prompt, I managed to insert 4 different assertions or test cases into my scripts.test.js file. This demonstrates how GitHub Copilot can generate comprehensive test assertions that cover multiple scenarios, from basic validation to edge cases like whitespace handling and field interactions. From this foundation, we can continue to test the email field as well as the entire form submission process, building a robust test suite with minimal manual coding effort. In software development, test patterns refer to established, reusable strategies and methodologies for structuring, organizing, and executing tests. These patterns help ensure consistency, maintainability, and effectiveness in the testing process. Test patterns can be broadly categorized into 3 main groups: the test pyramid, by focus, and by automation design patterns. The test pyramid includes unit, integration, end-to-end, and component testing. Testing by focus means tests are based on functionality, performance, security, and usability. It may also include accessibility, compatibility, and regression testing. Test automation design patterns provide structures for organizing test code, especially for larger automation frameworks. These include the page object model, arrange act assert, and mocking or stubbing. GitHub Copilot can help in all of the test patterns mentioned. Its level of direct contribution varies depending on the nature of the test. As you might deduce, Copilot is more powerful when dealing with code generation. In the demonstration that follows, we will focus on Copilot being used in component testing. Now what you're looking at on the screen is VS Code. It is split into 4 windows. On the left, we have our files and folders. In the middle is the editor window. Just below that is the terminal window. And then to the right is GitHub Copilot Chat, which you can open by clicking on the icon to the right side of the search bar. Now, as part of the test patterns, I can ask GitHub Copilot to help me write a component test. Notice on the left, where we have our files and folders, there's a components folder, and within it, there are 3 subfolders. One of them is the home folder. That contains 3 components or 3 files that make up the component. So over on the right side where my GitHub Copilot is, I'm going to go into the input box of that chat window and ask GitHub Copilot to add a component test for me. So my prompt is add a component test for the home component. I'll click on that right-facing arrow at the bottom right-hand corner of the input box, and I'll wait for GitHub Copilot to respond. Now I should mention that I have changed GitHub Copilot to be working in agent mode. So, with agent mode, notice that quite a few files do get updated. Over on the left side where we have our files and folders, notice that there are at least 4 files that got updated, and our home.test.js is the new file that was added to this project. Back over on the right side where the chat window is, I'll go down to the bottom right above the input box, and I'll click on that Keep button. That allows me to add the home.test.js file to the application, as well as update all of the other changes that were made in agent mode. Now, a component renders part of the UI onto the user's window in the browser. If we take a look at the home test which Copilot created for us, notice that it's testing the entire component. A component in React is a self-contained reusable piece of code. It can accept parameters, it can keep its own state, and it even renders a piece of the user interface that the user sees in the browser. I'll close the Explorer window so that we can read the content of the test file a little bit better, and notice that GitHub Copilot is helping us render the entire home component in memory. It's using 3 different libraries on line number 2. You see 3 different libraries there. Those libraries are being used to render the component, and then we will be testing that component to make sure that certain words appear in that component. Also lower down, there's another test. Once again, we're importing the entire home component or rendering the component, and in this case, we're looking for buttons. There's a particular button on the component, and it should say Click Me. Other than that, GitHub Copilot has even clicked the button on our behalf. So it can fire the click event on that button, and the behavior of that button is tested with the expect statement on line 15. GitHub Copilot is more than just unit testing, integration testing, and end-to-end testing. It can actually test components as well. This demonstrates how Copilot's learning capabilities can adapt to different testing patterns and provide comprehensive solutions for modern development frameworks. As good programmers, we always try to find vulnerabilities before they occur. Fortunately, there are certain patterns that exist, and Copilot is trained to recognize them. As you write code, Copilot will suggest secure alternatives, such as recommending the use of secure libraries for cryptography or authentication. It may even warn against the use of insecure functions or deprecated APIs. Copilot can sometimes recognize code patterns associated with vulnerabilities, such as hard-coded credentials or secrets. It will also recognize any insecure hashing or encryption algorithms that might compromise your application's security. GitHub has built-in security features like CodeQL, Dependabot, and secret scanning. These tools can be used to scan not only your immediate code, but extend to repositories and libraries. Copilot can automatically suggest and even open pull requests to fix known issues. With Copilot Chat, you can ask direct questions about your code. For example, just highlight a line or function and ask, "Is this code vulnerable to XSS?" Or, "How can I make this function safer?" Copilot can explain potential risks in your code and suggest improvements. This proactive approach to security testing helps identify and address vulnerabilities early in the development process, reducing the risk of security issues making it to production. The code on the top will work. The query will return results if any exist in the database. As you write the code, Copilot may suggest parameterized queries. If you ask about the suggestions, Copilot may respond that this type of statement is directly embedded into the final SQL statement. An attacker can manipulate the input to change the final SQL query structure. The code on the bottom is what Copilot will suggest. Here, placeholders are used for username and password, so user input is not directly inserted into the SQL statement. In the end, parameterized queries help prevent a direct change to the structure of the SQL statement. This approach separates the SQL logic from the data, making it impossible for malicious input to alter the intended database operation. The database engine treats the parameters as data only, not as executable code. By following Copilot's suggestions for parameterized queries, you create a strong defense against one of the most common and dangerous web application vulnerabilities. This is a perfect example of how Copilot can guide you towards secure coding practices. Web applications are vulnerable to cross-site scripting. This occurs when an application accepts untrusted user input and includes it directly in the HTML output. Without proper verification, this allows attackers to inject malicious scripts into the page viewed by other users. The malicious scripts can steal sensitive information, manipulate the page content, or perform actions on behalf of the user. In a case like this, Copilot will suggest using the text content property of the HTML element instead of inner HTML. The text content property will treat the username property, in this case, as raw text. Therefore, we can escape HTML characters and sanitize the input. This prevents any potentially malicious scripts from being executed in the browser, protecting both the application and its users. This demonstrates how GitHub Copilot can recognize potentially dangerous patterns and suggest safer alternatives. By following these suggestions, you can significantly reduce the risk of XSS vulnerabilities in your web applications while maintaining the functionality your users expect. A lesser-used feature of GitHub Copilot is its ability to suggest better-performing code. With the training given to Copilot, it can often suggest alternative implementations that are faster or use fewer computer resources. For example, It might suggest using a built-in method instead of a manual loop. It can offer a more efficient algorithm for sorting or searching. Copilot is good at refactoring code, making it more readable, maintainable, and testable. Copilot can spot code duplication. It can break large functions into smaller ones, or suggest better naming for functions and variables. If you feel a block of code or function may cause a bottleneck, just ask Copilot. In chat, questions like, "How can I optimize this function?" or "Is there a faster way to do this in JavaScript?" should be common. Copilot can analyze your code and provide suggestions to improve performance. Based on Copilot's training, it often suggests best practices for the language and framework you're using. This can include things like lazy loading, memoization, debouncing/throttling, and efficient data structures. It can also help reduce memory usage. These optimization capabilities make Copilot not just a code generator, but a performance consultant that can help you write more efficient, scalable applications. The JavaScript code on the left creates a new array called unique that contains only the unique elements from the original array. It uses a filter method, which iterates over each element in the array. For each item, it checks if the index of the first occurrence of that item in the array is equal to the current index in the iteration. The inefficiency here is that index of performs a linear search for each element, resulting in O(n) square time complexity. The set method is a better choice here and will be offered by Copilot. This method reduces time complexity to O(n), uses less memory, and is more readable. It is also more scalable and performs better with large arrays. This example demonstrates how Copilot can identify performance bottlenecks in common JavaScript patterns and suggest more efficient alternatives. The set approach not only performs better but also expresses the intent more clearly. You want unique values, and set is specifically designed for that purpose. By following Copilot's suggestions, you can write code that is not only more performant, but also more maintainable and easier to understand. Copilot can help with making your code more testable, which often leads to better performance and maintainability. Here, the function on the left is hard to test and to mock a database. The business logic is tightly coupled with the Express library. There is direct dependency on the database. Without an external database, this code is difficult to test. In this case, Copilot may suggest a pure function to get the user ID. This is easier to test with different inputs and mock database interactions. Notice that the getUser function accepts a mock or stub database as a parameter. This dependency injection pattern makes the code more flexible and testable. With this solution, you can unit test getUser by ID without Express or a real database, and you can test the getUser function by stubbing dependencies. This refactored approach not only makes testing easier, but also typically results in better performance because the code is more modular and can be optimized independently. The separation of concerns also makes it easier to implement caching, error handling, and other performance optimizations. By following Copilot's suggestions for testable code, you often end up with more performant and maintainable applications as a natural side effect. In this demonstration, we're going to change some of the settings within Visual Studio Code for GitHub Copilot. I have Visual Studio Code open with a simple application. An index.js file is currently active in the first tab. The point of this demonstration is how we access GitHub Copilot settings and how we change a couple of them. The GitHub Copilot chat panel is visible on the right side, but we won't be using it in this demonstration. According to the GitHub documentation, some of the changes you can make include enabling or disabling GitHub Copilot for all programming languages or for specific languages. You can also configure inline suggestions to show or not show. You can control how the chat panel opens. That's the chat window on the right side that we usually open by clicking on the GitHub Copilot icon, which is located to the right of the search bar in Visual Studio Code. According to the documentation, we can also change settings like keyboard shortcuts. You can edit the keyboard shortcuts for actions like accept, reject, next, and previous suggestions. In this demonstration, we're going to turn GitHub Copilot on or off generally, and then for a specific language, which is JavaScript in our case. To access settings, I'll click on the gear icon at the bottom left-hand corner of Visual Studio Code. This opens a context menu with options including Command Palette, Profiles, Settings, and Extensions. For this demo, I'm going to go to Settings. I'll click on Settings, and then I can search for GitHub-specific settings. In the Settings search bar, I'll type GitHub Copilot to filter to Copilot-specific options. This displays the GitHub Copilot Advanced Settings panel with multiple configuration options. What I want to change here is the General Enable setting for GitHub Copilot. Notice that there's an asterisk and then the value true. GitHub Copilot considers these as item value pairs instead of key value pairs or name value pairs. Over on the right-hand side, there's an icon that looks like a pencil. If I click on that icon, I can now change the item or the value for this first-line item within the Enable section of GitHub Copilot. Right now, the asterisk for the item is highlighted, meaning that GitHub Copilot will work for any programming language that I use. If I go to the Value section, notice that there's a drop-down arrow next to True. If I click on that, I get the option to choose either True or False. This is a binary option. I'll choose False. I'll click on it, and then click the OK button to the right of the drop-down menu. Now I have turned off GitHub Copilot for the entire Visual Studio Code IDE. To prove that, I'm going to go back to the top of the IDE where my Settings tab is. To the left of that is my index.js file that we had opened from the beginning. If I click on that tab now, I'm in the index.js file. I'm going to start typing some JavaScript here. Let x equals 5. Notice that no code suggestions appear. The familiar gray ghost text is absent because Copilot is now disabled globally. I'm going to erase this line now and go back into that settings interface. I'll leave the first setting that I made as it is, but I'm going to click on the Add Item button within the same area. I'll click on the Add Item button now and notice that I can enter my own key value pairs or item value pairs. For my key, I'm going to add JavaScript all lowercase. I'm going to tab over to the next box, which is the value box, and I'm going to leave that as true, then click OK. So my JavaScript is now set to true, but my global general languages setting is set to false. What I'm doing here with this setting is specifically asking GitHub Copilot for help with my JavaScript programs, but not anything else. I'll click OK here so that the setting is kept. Let me just check one more time. JavaScript is now true. Since JavaScript is true, I'll go back into my index.js file and start typing that same line again. I'll type let x again. Now the gray ghost text suggestions reappear for JavaScript code, demonstrating that language-specific settings override the global setting. This demonstrates how you can have granular control over GitHub Copilot's behavior, enabling it for specific languages while keeping it disabled for others, giving you precise control over when and where the AI assistance is available in your development workflow. In this demonstration, we're going to use GitHub Copilot to help us build a copilot-instructions.md file. This is the instructions file that Copilot will use whenever it gives you a response. I have Visual Studio Code open with the standard interface layout. For this demonstration, we'll focus on the GitHub Copilot chat panel, which is located on the right side of the interface. If it's not open, click on the GitHub Copilot icon to the right of the search bar in Visual Studio Code, and the window will open up. This is an Angular 19 project, and I'm going to use it to help me build the copilot-instructions.md file. The prompt I'm using is rather long, so I have copied it to the clipboard and will paste it into the input field at the bottom of the GitHub Copilot chat panel. I'll right-click in the input field and paste my prompt. I'll scroll up just a bit so that we can read the entire prompt. I am a new user of Copilot. I hear about the copilot-instructions.md file, and I want to create one for this Angular 19 project. Ask me 5 questions about the content of this file or what it should contain. I will answer the questions based on my own project, and I want you to take those responses and incorporate them into the instructions file. Ask me the questions one at a time and allow me to answer each question. That's my prompt. It's rather long, but I'll click the Send button at the bottom right of the input field. This arrow icon is labeled Send, to submit my prompt to GitHub Copilot. I'm using GPT 4.1 and I'm also in agent mode. As you can see, the first question has come back. GitHub Copilot is following my instructions. It's asking me, what are the main goals or priorities for this Angular 19 project? For example, code style, performance, accessibility, testing, documentation, etc. I'm going to be brief in this demo, so I'm going to respond with code style. So that's the first answer. Here comes the next question. Are there any specific coding conventions or style guides you want to follow in this project? Obviously, I don't know what these styles are, so it's telling me. Do you want to use Angular Style Guide, Airbnb JavaScript Style Guide, or your own custom rules? I'm going to go with Angular Style Guide. I'll click on that Send button again and wait for question 3. How should Copilot handle comments and documentation in your code? For example, always generate JS.comments only, or only add comments for complex logic, follow a specific documentation format, etc. I'm going to think here for a moment, and I'm going to go with JS.comments. So in my response, I will reply JS.comments only. I'll hit the Enter key. So that was my third answer. Here's the fourth question. Are there any files, folders, or code patterns that Copilot should avoid suggesting changes to or generating code for? For example, auto-generated files, certain configuration files, legacy code, etc. For this, I'm going to go with No and send that off. Now it's asking me a clarifying question. Thanks for clarifying. Here's the final question. Do you want Copilot to prioritize any particular Angular features or best practices when generating code? For example, using standalone components, strict typing, RxJS best practices, modular architecture, etc. I'm going to tell it to avoid signals. Signals is a new concept in Angular, and I'm just going to avoid it for now so that once we have more information about it, I can then include it in the next project. I will click on the Send button here and wait for the response. Here it is, and just like that, GitHub Copilot has generated an entire Copilot instructions file for me. All I have to do is click the Keep button. This blue button appears both in the chat response and in the editor window. Either location will work to save the file. I've saved the instructions file by clicking Keep. The problem is that the instructions file is not in the correct place. So what I'll do is go back into GitHub Copilot chat and ask it where that instructions file should be. Here's my prompt. The instructions file seems to be at the root of this project. Is this the correct place for it? Maybe it is because remember this is a single project. It's not a project for a team. For that, you would have to insert your copilot-instructions.md file in your repository. I'll click on the Send button and wait for the answer. It's telling me that yes, placing the Copilot instructions file at the root of your project is correct and the recommended location. Now I'll close the File Explorer panel and Chat panel to focus on the generated file content. Let me scroll through to review what Copilot has created. It's a rather short file, but in some situations, you will get a much longer file. For example, the idea here in this instructions file is to focus on code style throughout the project. Follow the official Angular style guide for all code suggestions and completions. Basically, all of the answers that I gave it have been incorporated into this copilot-instructions.md file. This demonstrates how you can collaboratively create a customized instructions file that will guide Copilot's behavior specifically for your project's needs and coding standards. Organizations may want to limit the context available to GitHub Copilot by excluding certain files, directories, or content from AI processing. When excluded, this content won't influence Copilot's suggestions or decisions. Content exclusion serves several important purposes. First, it protects sensitive data by preventing Copilot from processing auto-generated code, libraries, and non-source files that aren't relevant to development work. Second, it maintains code quality by hiding outdated, deprecated, or testing code that shouldn't influence suggestions, keeping focus on current, relevant code patterns. Third, it supports privacy control by excluding files containing company secrets, passwords, tokens, and confidential content, ensuring this sensitive information never gets processed by the AI system or influences responses. Content exclusion can be managed through GitHub.com's web interface for organizational control or configured directly in your repository using a copilot.yaml file or .copilot/config.yaml file to specify excluded paths or patterns. Let's examine this YAML configuration example. We exclude the entire node_modules folder since these external dependencies shouldn't influence code suggestions. We also exclude all files and subfolders in the credentials directory to protect sensitive authentication information and similarly exclude the My Documents directory. Additionally, we exclude any file ending with .private. For example, a file named mna.private would be excluded from Copilot's analysis. This pattern-based approach provides flexibility using both specific paths and wildcard patterns to ensure comprehensive protection of sensitive materials. Content exclusion is crucial for privacy and security when using GitHub Copilot, but has important limitations to understand. First, indirect leakage can occur when one file references content in another file. The referenced file may be picked up indirectly even if excluded, particularly when classes or types in protected files are referenced elsewhere. Second, symbolic links create similar issues, where one file points directly to another. The exclusion system may not catch these file references. Third, content exclusion is only available at business and enterprise subscription levels. Individual and pro users lack access to this privacy control feature. Finally, only administrators or organization owners can configure content exclusion at business and enterprise levels. Individual developers without proper permissions cannot protect files as expected using this feature.